Okay, so I think we'll get started. Welcome to our tutorial on building your own social virtual reality with Ubik. This is the first time we're giving this tutorial, and there's a whole team effort. So it's going to be an hopefully a really interesting experience, and we'll be learning a lot from it as well as hopefully recruiting a few new users for Ubik. So to start off with, I'd just like everybody who's on the team to wave and say hello, and we'll do a few introductions. So I'm Anthony Steed. I'm Professor of Virtual Environments, Computer Graphics in the Department of Computer Science at University College London. And I've been coming to IEEE VR for a couple of decades now. So I'm very excited to see some people I know come to listen to our tutorial. We'll do it in the order that's on the slide. That'll make it easier. So Sebastian, if you say hello.
Hello, my name is Sebastian. I'm a research associate in the Virtual Environments and Computer Graphics group at UCL, and my research interests are in graphics and networking and tools for building high fidelity virtual worlds. And I've been coming to IEEE VR for almost a decade.
Ben.
Hi, yep, I'm Ben Congdon. I'm also an RA with the Virtual Environments and Computer Graphics group. My research interests are also graphics and virtual reality open source software too. Yeah, I think most of my previous work has been on redirected walking. Okay, thanks.
Lisa.
Hello, I'm Lisa. I'm a PhD student working with Anthony, and I'm also a research fellow for the European project named CLIPE. My research interest is social virtual reality, avatars, and how to enhance communication of people and the trust in virtual reality. Thank you.
Hello, I'm Clara. I'm also a PhD student with Anthony. I'm in the same project as Lisa, and I am very interested in creating interactions with virtual characters, like learning, teaching them to behave more human, and ideally eventually like indistinguishably human, but we'll see where this is going.
All right, hi everyone, my name is Nels Newman. I'm also a PhD student at the VCG group at UCL. I'm on the European RISE project, also supervised by Anthony Steed. My research interests are mixed reality, human-computer interaction, and machine learning, very broadly. Thank you.
Great. So so this team isn't the only contributors to Ubik, but what we've got planned for you is a bit of the sort of background of where it comes from, a bit of the technology of how it works, and then some coming features, so things which are sort of experimental, and that's where the full range of staff come in, because some of the features that are being built into Ubik are to help people like Lisa, Clara, and Nels run their experiments at the moment. Okay, so to start off with, what is Ubik? So Ubik is an open source toolkit for building your social VR systems. I haven't said that it's for Unity because it's only implemented in Unity at the moment. We'll get into that later. We use Unity to develop most of our VR apps, though there's nothing specifically Unity about Ubik, and interoperability is something that we've been looking at. Importantly, it's released under the Apache license, which basically means you can do whatever you like with it. We would quite like you to cite the papers that we have written and are writing about it. We'd love to interact with you some more. We'd have, to some extent, we can help you build things that you want to do in Ubik. But if you are representing a company and you'd like to use it for your own a commercial product, go ahead. It's an Apache license, which is about as permissive as you can get. And it's a set of tools, services. There's a lot of examples, and therefore it's already quite a big project where we've used it for teaching, we're using it for experiments and so on. It supports a variety of platforms, and we'll be talking quite a lot about this later on. Most of what we've done at the moment is target the Oculus Quest and some of the other devices that we use in the lab. But importantly, we support connecting from desktop user interfaces and also from the editor. And for those who've known me for a while, this is just because I believe, trying to prototype things in VR is quite complicated if you can't just rapidly test things inside the editor or on the desktop, and you have to constantly switch to the head-mounted display. And I've missed out Webxr because that is actually a very new feature, which we'll talk about later, that we can actually build in Unity and deploy to Webxr contexts. And that's very important for some of the things we're trying to do, because it means that you just need a web browser to try some of the worlds. And it embeds a lot of our experience about collaborative virtual environments. So at the risk of this going badly very quickly, you can try it right now. It has a web context. You can build in Unity, push it to your browser. If you were to load this URL on the top, nexus.cs.ucl, I'll ask somebody to post it into Discord so people could just click on it. Somebody waved their hand saying they're going to do it. So post the URLs for the and also for the APK to download, and you can join, and you might see one or other of us drop off to go and chat to people in Ubik on Nexus. So so you can do that. You can download an APK, run it in your quests, or you can go to GitHub and check out the code and compile it. So so what I was going to do now is just pause sharing that and log on. So I'm just going to share a browser window now. You'll see all my book. Well, actually, I'll do it after I've done loaded Nexus. And I'll show you what you're going to see. Okay, so this is Nexus loading off our web server. You can load into this world. There's Ben, wave everywhere, Ben, because most people will be watching on Zoom. Curious Snake, I don't know who you are. You might want to you can change your name and move around if you like. And this system is set up, we're not all going to end up in the same world. This is an important feature. We are running a server. The server is just a Node.js system so that it's quite easy to set up and set up yourself. There's Nels with a very fashionable avatar. And now we're a group of 4. If anybody else joins, you'll get put into a different group because we've put a group limiting system into this demo, which you can download. So if anybody else joins, they'll get put into a different world. Now, it's very simple avatars for the moment. You can fire fireworks at each other if you wish. You can, well, you should be able to talk to everybody else in the environment. And what's happening is that the server we've provided is there to coordinate everybody, but voice connections and peer-to-peer connections have been set up between all the peers in the system. So we'll hear later from Sebastian that this is one of the motivations for us doing this, is all that we know, we are tracking all the data. Right, we're not going to log anything from you. We're not saving it at the moment. But this is one of our main reactions to trying to do some of this work in commercial platforms, is that we don't know what's happening with the data. Therefore, we can't protect it. We can't protect users. We can't get accounts, and we can't optimize. So for certain situations, you want to optimize how you use the network for the situation, and all of that's possible in Ubik. So I'm going to quit that and go back to my slides. You can carry on. So the idea would be that on Discord, if you're having trouble with that or don't know how it works, just post on Discord, and over the next 3 hours, there's 6 of us. So you can, post on it, somebody will help you. Although it's set up in a lobby system so that you will get spawned off into groups of 4, we can join you. So we know how to, we have a system where we can join your, so if you're 4 people that never used Ubik before and you want to post on Discord, we'll be able to join you and give you a little bit of a tour and explain what's going on. Right at the moment, if you join on web, you'll join other people on web, and if you join on a quest, you will join other people on a quest. That's just because we had some last-minute interoperability issues, but in principle, you should be able to join on a web browser and connect into a Quest user, and it should be a chat to you. And that's, you can see, Imagine gives you all sorts of capabilities for running experiments. Even just in the lab, it's a nice, simple way of running lots of things on one machine without, worrying about booting multiple things off one PC. So trying to run a head-mounted display, instead of worrying about supporting a second client, just use your web browser because that's nice and separate. And if you really want to stress us, you can open lots of tabs, and you can have all 4 characters yourself if you want, and you can have a nice conversation with yourself. So let me go back to sharing the bit about the slide. So we'll keep supporting you doing that throughout, and if you have trouble with that or want some help afterwards, please let us know. We've got an email address to contact us, and all else fails, the source code is available. So you could help us fix any remaining race conditions in the WebRTC signaling. Ben. So, all right. So this is what you've been doing. So it's a simple peer-to-peer demo, automatically put in groups of 4. We turn that off, you'll all just end up with 27 people in one room. That would work. It's just that if you're on a Quest, it might fall over. That's a lot of peer-to-peer audio. And we'll hear later what we're doing about scalability. So we designed it really for small group interactions, types of experiments we run with small groups. The types of thing we want to do with teaching, which are again small groups, but you'll see some work on scalability, and actually compared to some of the commercial platforms, it already scales pretty well actually. So yes, it's lots of things have been done right. Okay, so in the remainder of the time, if you want to drop in and out or come back, what we'll do in the first half, because this is a long tutorial with 2 1.5-hour sessions, is myself and Sebastian will give you a bit of an overview of social VR and why Ubik is the way it is. And that'll be quite detailed. If you're interested in some of the background to these platforms, that's the section for you. And yeah, it's be quite broad ranging, and then I will be quite broad ranging, and then Sebastian will give you lots of the sort of high level features. So if you experience with other platforms, you've got a lot of comparative detail there. After the break in the second half, it's a lot more practical. So Ben will lead you through a sort of tutorial on how to build an app. So you can either just watch along, but we will invite you to check out the code if you wish. Open Unity. Ben, you might want to post the version of Unity that we prefer into the Discord, and you can build along. This is based on a tutorial we use with our students, and so if you are thinking about using Ubik for teaching, then we'd be very happy to sort of discuss with you, sort of even just using some of these tutorial assets, and we've done it in a couple of slightly different ways with our students. And then Lisa, Clara, Sebastian, Ben, and Nels, in order, will present some features that are more exploratory. The source code for some of them is already available. Lisa, she actually talked about yesterday at the open source workshop, which is about using not just the cartoony avatars, but the Rocketbox avatars. And all of the assets that we're showing are also open access. So that's one of the, again, another reason why Ubik exists is that we can actually give away experiments, the source code for experiments, without treading on anybody's toes on the asset store. Because if you've used Unity, you'll know that as soon as you download anything from the asset store, it's not open source. Because even if it's free, you're not allowed to redistribute. Okay, so that's the schedule, and those are the URLs. So you can get more about Ubik from ubiq.online. That's got a link to the tutorial page for this tutorial, where we'll post all the assets afterwards. The main thing is it's on GitHub. I forgot to put a link to a VRST paper, but you can find it on ubiq.online. And if you want to contact us in the future and the other team members, then you're welcome to contact Ubik, ubiq@cs.ucl.ac.uk. And we're happy to take questions at any point. Either just put them in the chat or put them on Discord. And as we're speaking, one of the team will just, if you don't want to flag up, raise your hand now, or you want to raise it at the end of it, want to put it in to raise it at the end, then one of the team will flag it. I think Clara is going to moderate questions to take to us. So, so next is the bit about the overview of social VR platforms. So, obviously, social VR platforms have been around for a very long time. And at the moment, if somebody gives a talk like this, you'll usually get this quote from Snow Crash, which I do like. And it's the sort of the origin of the term metaverse, and gives an idea of what we're expecting. So what do we like to do? We're in a sort of virtual world with lots of people. There's somehow you're meeting, you're traveling, and it's all drawn by his computer and shown in a virtual reality helmet. So this is highly motivating at the moment. And of course, it's from 1992. Back in 1992, people were trying to build this. And they've been trying for the last 30 years. So we have lots of examples of existing social VR systems. So to give you a bit of the background, there's, from the military side, there's been a lot of the sort of multi-user virtual sort of immersive simulations using networking, often specially constructed networks, back from the early 90s. Well, from the 80s and 90s, and possibly even before. I'm a little out of date on my research on the sort of background to these training simulators. And at this time, of course, the distinguishing feature is mostly the screens and the computers, because each simulator unit is costing probably hundreds of thousands of dollars or pounds. But it's networked, and if you're interested in the history of these systems, the early papers are from systems like SimNet that talk about how to support thousands of moving entities in a shared virtual environment. This is what I did when I was a postdoc. So this is an academic system from the early 90s called DIVE. It's a distributed interactive virtual environment from the Swedish Institute of Computer Science, which I worked on from about 1996 for about 6 or 7 years. I helped build some of the features in one of the later versions. And this is a demonstration of visiting UCL with multi-party audio. So back in 1999, this was already possible on relatively expensive computers, well, moderately expensive computers. These are desktop workstations now. Dive supported groups of up to about 20, probably communicating in the same room. And it had really lots of novel features in there. Spatialized audio. It supported very large environments. And it was a bit like a metaverse. You could travel between places here. And I keep promising that I will make some more retrospective videos about Dive, because it's got some interesting features and it still works. So I demonstrated it to the students into the lab about a month ago. So what made that work was the fact that it was based on an academic backbone. So and it's something called the multicast backbone, which allowed all of these people from different labs to communicate together without using up 20 times 19 links between everybody. It was sort of using a feature of the internet, which is unfortunately badly supported in anything larger than the metropolitan area now. It might be supported on a university campus, but home ISPs just don't support it anymore. Well, most of them don't support it anymore. So there is a long history. So there's a long history of other systems, right? So I've neglected to mention things like Doom and Quake, which were obviously many people's first experience of network graphics systems. They had precedents, right? So there were predecessors systems which were also multiplayer games on internet, played on campuses by people like me when I was an undergraduate. And you can trace some of this history back to Muds and Moos, systems like Habitat, SimNet, Alpha World, Active Worlds still exists. You can still go and visit that if you want to type that in. That's one of the longest running now sort of online 3D worlds. And to some extent, you know, if as a community, we can probably be a little bit critical of all these people and the sort of crypto community that are reinventing things with NFTs and other sort of blockchain technologies that look remarkably like Active Worlds, which has been running since the early 90s. You've got systems like Black Sun and the whole VRML history, and systems like Second Life, which again are still running. Now, at this point, I will just plug a book which I wrote with a former student, Manuel Oliveira, and this is now 10 years old and showing its age, where we sort of reviewed the sort of technologies that are required for sort of shared virtual environments. We had a lot of sorry, could somebody just say something? It just told me my audio settings changed.
No, it works fine still.
Yeah,
Okay.
I can hear you just fine.
Again.
Yes.
I can
Okay,
hear
all right.
you just
Sorry.
fine.
So
Yeah.
my audio settings just reset for some reason. So hence the bigger headphones, which make my head look even larger. So this book sort of reviews a lot of this precedents, technology from the 80s, 90s, and through the 2000s up to about 2010, and now. And gives you some of the background. But of course, we wrote lots of examples. They're all in Java, not Unity and C#. So it's showing its age a little bit. But a lot of these social systems, they all have some common high-level features. So what we're mostly going to focus on is the first of these, which is the sort of real-time social virtual reality, which is the primary awareness. So as you saw in Ubik, if you manage to launch it, you see a group of people in a small island. That's just a demo world that you can interact with, you can wave at, and so that's what we call primary awareness. And we're not going to talk about some of the other issues that Ubik doesn't address, issues such as secondary awareness and tertiary awareness, which is what the metaverse is more about. We're not going to claim that Ubik is one step is a metaverse. It's one step, it's one part of the experience. And in a talk about metaverses, I would start going on about how secondary awareness and tertiary awareness are really what some of the big players like Meta and Microsoft are really interested in. It's sort of how do you find people so that you can have a synchronous communication. And things that are more like that today are things like PlayStation Live, Xbox Live, PSNet, and Discord, where you see potentially hundreds or thousands of people, then you scope that down to people you're actually interacting with, and then you want to kick off a sort of focused communication, which is where the sort of virtual reality has its main power. And then there are sort of lots of issues in these systems, and you can categorize them based on editing capabilities, how you publish and how you govern them, how you own, and rules, which are all sort of really fascinating topics, which I'm afraid are a little bit out of scope for today, because we'll try to narrow down on some of the issues around social virtual reality. So some of the research questions in that sort of primary awareness, then, if you did try the demo, or you're following along with instructions on Discord and you try it in the rest of the session, what should users look like? So we chose those cartoony avatars because they're CC0 assets, and we're allowed to redistribute them. How should we build the software? So what sort of the tool chain is? How should we deal with things like latency? So Ubik is peer-to-peer to sort of just pick the best option at the moment for the latency controls, for the latency control. How do the users want to interact? So every social VR system has a different set of tools. We're interested in research on how you would, what sort of controls are best for users. How do they move between different software? So one thing that's inevitable, and we are very interested in, and it's one of the ways in which we might extend Ubik in the next few years, is how to make it interoperable so you can run multiple applications at the same time. How do you deal with some of the challenges of the metaverse, such as having a single point of entry? What does a door look like between two apps, and so on? And how do we control access and rights? So this is one of the active projects at the moment, which we won't talk about today, but is ongoing over the summer. Is if you've got a bigger space, how do you embed the types of rules that, say, Verbella has about who can speak and who can't speak, and promoting people and so on. So again, those are well studied in games, and they're well studied in moves. They're very, very hierarchical rules in moves when I was using them. Sort of complex hierarchies of roles and responsibilities, and tools you had access to. And at the moment, if you go into a sort of social VR system, many of the commercial ones, that's it. You're just there. All you can do is chat, move things around, and you don't get access to the editing capabilities, with some notable exceptions. Okay, so at the moment then, as people obviously interested in social VR, you've probably got quite a lot of experience with one of these, or a platform a lot similar to one of these, where you've essentially got a walled garden. And this is something that you can read in papers at this conference and other conferences, that people have tried to, well, they have used tools such as sort of VR Chat, Altspace, and Rec Room as places to study. So you can get some fascinating results by studying users of those, surveying them, so on. But you have very little control, and in particular, with a couple of minor exceptions, you can't really sort of send data out of these systems. So they're walled gardens. There's lots of risks associated with using these for research. The first one of which is that they're a moving target. So you're at a bit of a risk of, you write your experiment and then you get the infamous waiting for update message when you try and run it. At which point, your students start quaking and wondering if the software is going to actually run properly after this update. Now, of course, that's stabilized a lot over the last year, but it's still a bit of a risk because you don't control the platform. And there are other downsides. If you want to ask me about them afterwards, that is a very fruitful topic for discussion. So you know, it'd be nice if we had a sort of open platform for this, for partly for research, partly for, you know, to promote standards, partly to you know, provide teaching. So it would ideally be a completely flexible platform, you know, supported by lots of users, lots of groups, designed for academic research and teaching, compliant with security standards, so that it's auditable, and supporting all the types of application we want to build. But that's, you know, a long way off to have a sort of open, completely open system like this. So at the moment, we're still in the sort of realms of building applications, and that's what Ubik's purpose is: building your applications, asking some of those research questions, and sort of doing research, you know, working in the lab, and working at a slightly smaller scale. Okay, so I will, in the next 20 minutes, just talk through some of the challenges of these platforms, and give you a bit of a flavour of some of the things that we've started addressing in Ubik. So, challenges of social VR. So, the first is that you actually have to build quite a lot of things. And there are demonstrations of sort of packages that you can download. In our first paper on Ubik, that was at VRST last year, we sort of did a comparison to, say, something like Photon. Now, many of you may have used Photon, and to implement your system, but it actually doesn't give you a lot of facilities. If you were to say to compare it to, in this case, Second Life. So a lot of the software complexity comes from services that we don't need in our lab. We need certain things such as real time. We need rendezvous so that you know where to go, and we need real time communication between the people. And we're not dealing with persistence. We're not dealing with object ownership. We're not dealing with the sort of things that happen inside the Second Life universe, such as multi-domain hosting. So if you know about the history of Second Life, you may know that the protocols are reverse engineered and available so that you can set up your own universe of servers and connect a client to it. And there are multiple clients that aren't written by Linden Labs. So there are quite a few analyses of these. This is a paper which I can recommend on that, which Manuel Oliveira and I wrote, which sort of goes through some of the, what it is that you're doing if you're going to build a very large scale sort of social virtual reality system. And this paper has on the order of 270 citations and was one of the key resources in writing the book. So consider this a sort of preview of what you're getting in 500 and so pages in the book, and that's freely available online. So we just say that what we're doing, the point to make there is that there isn't an architecture that fits everything. People that claim that they're building a metaverse are not understanding the problem, because there just isn't an architecture that fits all the requirements for everybody's social virtual realities at the moment. It's a very long way to an open architecture for some of these. And you can just start by thinking, if I've got an application in Unity and an application in Unreal, what on earth are they going to talk about? How am I going to, you've got to move to a different level of abstraction if you're going to build an open architecture, and then still deal with the idea of how do I get assets? How do I build the world, and so on. So we could have a discussion afterwards about Webxr and if that's a solution. And at the moment, my first response to that is, well, we published a Webxr. And the problem is not running it in a browser. It's where does all the content get assembled, and how do scripts run and so on. So that's a fascinating problem, but there isn't an open architecture to be had in just by sitting down and talking about it. So Ubik is going to focuses on the different ways to do the primary awareness at the moment, and it's very malleable, so you can change some of the decisions that we made in creating our demonstrations. The second thing to talk about is the internet, and it seems a little bit churlish these days. We sort of rely on it for Zoom all our time, but a lot of the games and systems that we're using sort of only work because there's a massive engineering effort gone on the server side to hide some of the features of the internet, or at least not hide them, but shape them in a slightly different way. The real-time graphics applications are not standard network applications. That's because they've got multiple sources. They're highly variable in the amount of data they require. So you might say that it's a bit like, just Zoom, but plus. But if you actually had a look at how Zoom works, you don't want to build the backend for it, right? So they've got lots of server hosting that sort of hides some of the complexity. And there are 32 participants. You can be very sure there isn't 32 peer-to-peer connections going on between the participants. There's a server network that's sort of ingesting data, sending it through their backbone network between data centers and spitting it back out again. So the idea that in social VR that some information changes very quickly and is very important, so because our locations, and some things are very important, sort of underpins sort of how we choose network services. And there are choices there, and we enable those choices if you look under the hood of Ubik. So the internet is built to move bulk traffic. It's not for end-to-end speed. Well, you can't reserve bandwidth, except some exceptions. Latency and bandwidth will vary. Streaming for audio and video will buffer. Loss is not so important for video. So it just wasn't built to deliver synchronous experiences. Now there are standards there, like WebRTC, we're exploiting inside Ubik for the voice. So there is progress, but at the best you can do as a lab at the moment is either run services on your local network, or if you're going to work a large area, you do peer-to-peer, and that's currently what we're doing with our networking. But it's just a choice, so it's completely flexible, and Sebastian might mention that. So the key lessons there is social VR systems will need to deal with latency and related internet issues. Client server and peer-to-peer both have their roles, and then if you're implementing these systems, generic toolkits for synchronizing objects do work to some extent, but you'll rapidly find out if you're going to develop the code that you want to do something specific about synchronization. So we actually exposed all of that to the user, to the developer, so that they can build their own synchronization mechanisms if they like. Okay, interactivity. Every platform is different. And one of the things you have to learn when you go into any of the social VR systems at the moment is what buttons do what, how do I find people, how do I message people, can I have a private conversation at all, can we jointly manipulate objects? If you see this lot and me go into a social VR system, one of the first things we'll do is try and throw things to each other, then we'll try and hand them over to each other. And before we committed to build Ubik, we spent a whole summer sort of kicking the tires of all the different systems, trying to figure out, did we really have to do this? And you might know that if you've been at IEEE VR, I've given talks where I've sworn I'm not writing a toolkit for years, and then we did it. So I didn't, because we just didn't find one that we could use for all the features that we wanted. And so here we are. So so the rules are all different. Another paper I can recommend from my group, this is from a master's student last year, sorry, the year before last, Kershi, we did a sort of comparison of some of the platforms using a sort of cognitive walkthrough method, which is a sort of old, well, not old, sort of venerable technique that's used to evaluate software. And the idea was that we're going to use the concept of people meeting and doing something in virtual reality as a sort of goal for a walkthrough method. And then we can compare the platforms and see where people struggle. So if they're going to try and find a friend in the social VR platform, what do they do? Part of the output of that has been some observations about particular problems in particular systems. So for example, let me pick one at random. It's not because I don't dislike the platform, but in Mozilla Hubs, if you've tried it, and we did a lot of that, of course, at IEEE VR 2 years ago. It's actually quite difficult to tell who's interacting with an object, because interaction rates are sort of can be arbitrarily long. So the closest person to an object pointing at it is not necessarily the person controlling it. That's something that's obvious for a student project to look at, is how can we tell who is doing something in the virtual environment. Okay, so sorry, that was actually the picture of that. Sorry, I got out of phase with my slides. Every platform has problems, and I don't have time to talk about more of them. Okay, so some key lessons there. The platforms vary a lot. None has the design right. Very open area for novel design once you have a working system. It's getting to the working system, which, if you just start from scratch, will take you a while. Ubik gives you a sort of a very simple sort of way of getting started. We've got an abstract we've got a simple abstraction for interaction techniques. So if you wanted to run it on a novel device, and Nels will talk about several novel devices later, you just have the main thing you need to implement is the way of interacting with that device. So what buttons do what, and are there gestures and so on. And then you can get right into it. How do people control shared objects and so on. Avatars, right. So this is me in 3 of the platforms. This is what I'll look like in Verbella tomorrow, or if you're walking around that. This is a recent shot of my Rec Room avatar with our new capes. We're still trying to figure out why we all got capes last week, a couple of weeks ago. We assume they mean something. 2 of us have the same cape. We don't know if that means we're supposed to collaborate. Possibly we should read some more documentation. And on the right is the one on Altspace. Things that you might notice is the middle one's the only one with the same hairstyle as me, because in Verbella there's no partially bald people, and in Altspace, that's about the closest, is receding hairline, but not bald. So it's not a serious sticking point. They've all got jackets on. They all look sort of semi-formal. You can imagine that's what they want to do, is support sort of casual professional meetings. But hairstyles is one of my sticking points. I can't make something. Most of these platforms, I can't make something that looks a bit like me. Well, looks more like myself. So this is the area where many of us work, and workshop yesterday, and a parallel workshop now is looking at avatars, what we want to look like, how we want to use the body tracking, and we've done a lot of work on this in the lab in social VR over the years. So one of the things we're doing at the moment is re-implementing some of those experiments, so that we can show that the results are still valid, and then we can get into some of the other issues, such as how much users want to customize their avatars and so on. Okay, I think just to point out, one of the issues that we do want to get into over the next few years is how people adapt and run with avatars, and how they socialize with them, and how they adapt them to their ongoing use. And I talked a little bit about that yesterday at the workshop on intelligent virtual agents. Sort of what do we really want from avatars over time? So at the moment, we are using the assets you can see on the bottom right and you see in the demos, and we'll hear later about an alternative. Then fifth area, scenarios required rules. This is one of the sticking points in using some of the commercial systems was how much control do we get about what happens? So can we, for example, how do we get students into rooms? Can we force them to go places? And the answer to which is no in most of the platforms. There are platforms that allow this, but then there's other downsides. How do we do dynamic content control? How do you act as a games master or a wizard in the system? How do you get into roles and privileges? So the very obvious exposure to that is, again, something that Lisa may touch upon, which is management of users. And in an experiment, for example, we've got the tools in Ubik to sort of bring in users, get them all set up, and then mute them or put them in places to run the scenarios. So things that would just not be possible in a commercial platform because they could be exploited by nefarious people. Our, of course, assumption about most experimenters is they're not nefarious. We hope you aren't. Hopefully we aren't. Okay. And then a quick point to make about data flow and ownership. One of the things that worried us, especially under the COVID-19 situation and having to run studies remotely, was satisfying our data protection laws. So again, it was a black mark against some of the platforms we got close to using, like Spatial. If you took one look at the network traffic, you'd all see it going via Austin, Texas. If we get participants in and they have to create an account, that's technically against our data protection laws, which a university like ours has to pay close attention to. So again, that's a management issue that we've addressed head on. Okay, so key requirements for this part, where very few systems have role management and scenario management. Ideally, we want to control the whole thing. We want to have oversight. We might want to monitor the system. We might want to manage users. And so Ubik provides a server. Nexus is, as I said earlier, it's a Node.js process running on a server at UCL. You can copy it, run your own. It's in GitHub. So although you're connecting to our server, you can run it on your own. You can run your own server, and there are instructions on how to do that in the documentation. Okay, so what next? So if you want to, if you are implementing, this is in a rhetorical sense, the answer to which is of course going to be use Ubik, give the game away. You can work with commercial platforms depending on what you want to do. It's hard to make the exact scenarios you want. There's a risk of code rot, there's a risk to services, there are some privacy concerns. Webxr, we're not discounting Webxr. It can provide some necessary features. And of course, at the moment we're using it as a publishing platform. So you can target demos, and Ben will talk about that later. But there are some constraints there, which come partly because of the state of Webxr at the moment, but also just because it's a web browser. Again, I can answer questions about that in Discord if there's time. So, okay, hence Ubik, that's why we're here. Amongst other things, we want to allow exploration of all the issues. It's a complete system. It supports niche use cases. It's useful for teaching, and we've used it for teaching ourselves. And it supports experimentation, and it's open source. So for us, that basically means that we're trying very hard to publish experiments. There are still small sticking points, but one of our key motivations has been teaching and data privacy, and also releasing the code so that people can run some of our platforms themselves and reproduce our results or show us where we went wrong. So I just let this run for a minute or so before I start stealing Sebastian's time. We used it for teaching last year. These are on the website, and they're actually, these are 3 of the student projects that made their code open source. So on the left is a demo that a group of 4 students did in a couple of months, part-time. And it's got some features in it. They built a 2-scale maze. So this thing on a table is actually a sliding block maze. You slide it around, it's manipulating a maze with people also running around on the inside. When you look up, you see giant people, which are the other collaborators. And we just took one look at that and say, how do you actually do that in Ubik? Because it wasn't a feature we built in, but they figured out how to do it. And I think the trick, and Sebastian could nod, is that there are actually 2 scenes here. There are 2 different network scenes that have just got the same information in them at different scales. This is an early version of Ubik. The students did this, they made the code open source. We've just updated it. So if you want to see a really complicated example, or you're just interested in trying something a lot more sophisticated, you can check that code out. They've made it available on our GitHub. And on the right are 2 more examples. What's it called? Transballer is a sort of puzzle game where you have to make pipes for balls to fall through. Very sophisticated demonstration. And the bottom right is Pizza VR, where you can make a game where lots of people have to collaborate to make pizzas and serve them to hungry guests. Okay, so that's the end for me. I think I'm right on time. Yeah, I'll answer questions in chat, but right now we will hand over to Sebastian, who can give you some more of the gory detail about the architecture and some of the things you need to know if you want to evaluate it, given that you've got some experience in this field. Thanks.
Thank you, Anthony, and good morning, everyone. So yes, what I'd like to do next is go into more detail than we've gone before in any other venue to tell you about how Ubik works, and also try to explain some of the design decisions around it, given the goals that we've just discussed. So to recap, Ubik was created about a little over 2 years ago out of necessity. So we had to move our virtual environments course online with very short notice, and we needed a platform to support our networked first coursework. And as we were looking at what was available, we began to realize there were good reasons why we were having trouble finding something suitable for research and teaching. And it is because the goals around things like data protection and transparency or accessibility directly conflict with many of the monetization models of commercial platforms or frameworks. So our goals for Ubik are really to address these requirements that we are quite confident will never be addressed by commercial packages. And these requirements are to support, firstly, to support network VR experiments or applications which have non-traditional architectures. These are the systems that previously would have required researchers to write their own netcode. Secondly, to be accessible to small teams and researchers without networking experience. That is, we can use it for teaching without having to do an entire module on networking. So the idea is that how it works is obvious, it's easy to find out and see exactly what it is doing at all stages. And finally, for our own use, to make it easy to build distributed experiments. And this is done by 2 parts. Firstly, by implementing a lot of the boilerplate stuff, things like logging, and also being compatible with external constraints, such as data protection regulations. So with those in mind, I'll just start the tour by reviewing exactly what Ubik is and how we expect users to interact with it. So Ubik is a software project that implements the networking and social aspects of a distributed VR system. So it's written primarily for Unity at the moment, and it consists of Unity code, very comprehensive samples, and supporting materials like complete documentation and a Node.js server. And the way we would imagine Ubik being used is users would say, download the project. They would copy the hello world sample scene. They might swap out the environment for their own. Perhaps they would write some networked objects, put them into the scene, and they could then build an executable or even a Webxr build that they can then ship to their customers or participants. So Ubiq is a library that is meant to work with other first and second party packages. So it's not an environment. It's not a complete layer like something like VRTK. It's not a creator consumer platform like Roblox. Rather, it's a package that is totally focused on networking and social VR. And users primarily interact with Ubiq through code. Ubiq is at its core actually a fairly low-level message passing library. Now, which might sound odd given our goals of accessibility, but actually remaining low level is quite necessary to support transparency and some of these niche use cases that we're interested in. So we can imagine networking libraries kind of on a high-low spectrum similar to programming languages, where low-level libraries being the operating systems, networking APIs. In the middle section, you might have some decorators you attach to your classes or checkboxes, and at the far end, you have engines like Unreal, where the entire way that the game is structured, the way the code is written, has networking inbuilt at its core. So the networking just works in that case. And in this case, Ubiq is actually fairly low level around here. So in Ubiq, users create, dispatch, and pass their own messages. We do provide a number of helper functions that hide certain details, so they don't need to know the intricate details about things like serialization. But ultimately, users do need to have an understanding of the concept of there being multiple scene graphs, like a copy at each process, and these processes communicating, sending messages in order to keep these multiple copies of the scene graph in sync. The vast majority of Ubiq's high-level functionality is included as very comprehensive samples and subsystems, which we do try to keep as decoupled as possible. So if you're building an experiment or application that doesn't need voice chat, for example, you can just delete that whole subsystem or turn it off, and the rest of the system, the application, should remain completely unchanged. And the motivation is that we would fully expect some experiments to need to modify or even replace these subsystems entirely, especially when it comes to things like avatars, for example. And the samples themselves, there are a small number because we're a small team. We don't want to maintain hundreds of different samples, but they're very comprehensive, and they are built in such a way that we would fully expect students, say, to just copy one and hack on it to implement their final application. Okay, so that's the overview of what Ubiq is. For the next part of this talk, I want to go through some core concepts, starting with exactly how you would write code against it. So Ubiq adopts Unity's component-based programming model. So I'm guessing most people are familiar with Unity here, but just a quick overview. If not, in Unity, user code is placed in components that are attached to objects. And these components, the code in those is invoked via callbacks from the main engine. And the idea is that different components are responsible for different logical functions. So if I have an object here, say a torch that I carry around in the world, one component will be responsible for drawing the textured mesh to the screen. One component would be responsible for making the crackling sound. One component would be responsible for interacting with the lighting system, one for the particle system to draw the fire effects, so on and so forth. And each of these would be configured independently and would interact with its own subsystem. And Ubiq follows the same approach, and we would expect users to write new components that implement the networking functionality of entities in the world. And so we provide to do this, we provide a set of interfaces that users use to create what we call network components. And these are basically standard Unity components that send and receive messages using Ubiq. And when a message is received, it's handed over to a callback through a comment method like any other Unity system, like you were using on trigger enter or the like. And the idea is that by imitating Unity's existing models, Ubik becomes immediately familiar to existing Unity users, which hopefully improves coding efficiency and aids discovery of its various features and APIs as well. For communication, Ubik takes a lot of inspiration from the scene graph as a bus approach. So put simply, with this approach, objects talk to other objects. And most commonly, these objects are objects in an object-oriented programming sense. They are basically instances of Unity components or network components, in our case, on different game objects in the scene, and they talk directly to their counterparts on another number of processes. So a single environment, a single scene, would have many different objects of the same or different types, all talking to their counterparts in parallel to keep each one individually synchronized. Ubik derives quite a lot of information from the scene graph. So users first place their network components on game objects, obviously being Unity. When the application starts, these networked objects, they associate themselves with a network scene. The network scene is the most important component in Ubik, and this is like the root, if you like, of the scene graph for the networking. This network scene, this component is what actually creates the underlying connections, dispatches outgoing messages, and routes incoming messages to the correct Unity component. So all applications, all Unity scenes must have a network scene. In Unity, we can't create new subsystems like physics. So in our case, the network scene is actually implemented in a component which is attached to an actual object in the scene itself. And this game object can also be used to host other components that implement the different decoupled services like avatar management, like voice chat management, and so forth. But having the network scene on a game object does actually have some advantages. So note in this screenshot here, the network component in this case is not a direct descendant of the network scene, even though I said it's kind of like the root. In Ubik, when components find each other, we use a search process which finds the closest component or closest object that we're interested in based on the metric through the scene graph, even if they aren't in the same branch. And this allows us to do things like, for example, create prefabs or prefab variants of network scene instances with different capabilities and different variants of prefabs of different environments, say with different networked objects. And these can then be mixed and matched at will across different Unity scenes. And these will find each other without having to have direct references in the editor. And we use this mechanism a lot in Ubik across different systems, and it does offer a number of opportunities that would be difficult to achieve otherwise. So for example, in our local loopback scene, in which one of the samples we provide, we have a single Unity scene with two copies or instances of the Hello World environment that effectively correspond to different peers. So these two scene graph branches, they communicate effectively as if they were running on two different computers, but because they're in this one Unity scene, you can develop and debug code under one process and one debugger. Alternatively, in prior scalability tests, we actually created two network scenes, basically two peers, if you like, that both affected the same single environment in one Unity scene, but one joined a command and control room and would manage the metadata about the tests, and the other one would actually be like the equivalent of the peer that was a member of the room. And these were actually running on two completely different servers even. So this approach offers a lot of flexibility in how the Unity scenes themselves operate, or even what a Unity scene means in the context of the application or how it's built. So I use the word peer, but then in Ubik, we call nodes or processes with a network scene peers. So Ubiq is logically inherently peer-to-peer, and this is because, put simply, peer-to-peer communication is in some ways the most flexible architecture, in the sense that other communication models can be implemented on top of it with the correct filtering or addressing, but not always vice versa at the actual network level. So logically, all peers in Ubiq communicate in an end-to-end or mesh manner. This weird diagram is trying to indicate that when you send a message, it's received, you talk directly to peers, but you don't necessarily have access to the connections between all those peers. So you send messages out to the messaging layer, you know that you're sending them out to one of a number of peers. You don't necessarily know how that's happening. So practically, you can have different architectures underneath. So a peer is basically a network scene, the one that holds the connections. A peer group is effectively all the peers that communicate when you send a message. And you create these peer groups by having the network scene create the underlying connections. And so you could actually have a true mesh arrangement here, but most cases we expect would use the server relay or server fan out system, where you have a connection to the rooms, to the server hosting the code required to use the room system, which I will talk about in a few slides. Significantly though, as I said, at the messaging layer itself, there is no information about what other peers are connected. By default, the network is simply a black box to which messages go in and messages come out. And we've designed it deliberately like this for a couple of reasons. The first is that it encourages user code to be written in a way that is agnostic to the architecture and the number of peers themselves, which we hope is likely to make it more scalable and allows us to actually change the architecture out from under the various components that the user writes without ever actually needing to change their behavior. And it also allows us to have different systems to manage the peer groups. So we can have the server system, which we'll discuss very shortly, or we could do local network discovery with broadcasting, or for fixed installations or experiments, you could even just have a component which tells the network scene component to create a set of connections to predefined points defined at compile time and build a group that way. So how do objects communicate through this black box, the important bit? Well, I said previously that objects talk to other objects. So instances of network components talk to other instances of network components, Unity component to Unity component. In Ubiq, each of these objects or components has an identity. When you send a message onto the network, it is sent to a particular ID, and it is received by every object with a matching ID. That is, the messaging layer implements application layer multicasting. So say, for example, I was a peer and I had an avatar. So I would, via some mechanism, advertise the fact to the other peers in the peer group that I had a certain prefab describing my avatar, and the instance of that prefab has the ID 1. So when other peers join, they would see this advertisement, they would create a representation of me on their side and give it the same ID. On each frame, or every n frames, my avatar would send a message to ID1, or with ID1, its own ID, and due to the application layer fan out, a copy of that message ends up at the counterpart to the instance of this prefab at each other peer. So my avatar doesn't need to know how many peers there are, if any. It only sends one message, and peers can come and go over time. They'll receive my avatar messages as they do, again, all without my user code needing to be aware of it. Now, the object IDs themselves on the wire are 80-bit values. At the messaging level, these IDs are atomic. They're just one number. Logically, though, in Unity, they're actually built up from two parts: a game object or networked object ID and a component ID. And again, these follow the Unity model where the object ID is kind of meant to be like the game object or instance, and the component ID is like the class. So the object ID typically is created and possibly synchronized dynamically at runtime, and the component ID is typically fixed and is associated with the class itself. And the motivation for this is that in any network system, when an object is created at runtime, other peers or clients or whatever you want to call them will need to know the location or identity of that object on the network in order to communicate with it. And so it must be synchronized between all participants in order for communication to take place. This can be a complicated process depending on how it's done. And what we don't want is every network component that especially new users write to have to be aware of it. Especially where, say in the case of an avatar, a single entity, or what is conceptually a single object, is actually built of a number of different network components. So say again, in the example case of my avatar, say I had an avatar prefab, which has a networked object ID. When a new peer joins on the other side, a new avatar is created, a new instance of that prefab is created to represent it with the ID that it advertises. Now, this avatar may have network components for controlling, say, the hands and the skeleton. Let's say I, as a student, wanted to add a new component to control eye gaze. Now, I can now write this component, and I can add it to the prefab for this avatar, write my code to control the eyes based on just two numbers, which are exchanged by messages. Now, when that prefab is instantiated at each other peer on the network, my component will, by default, by design, only talk to its counterpart on those prefab instances. It won't know anything about the avatar management system that created those instances, but it will only talk to its counterpart without me as a user having to do anything else. So while usually this is how it will work for the majority of network components. So usually an instance of a network component will talk to its counterparts of the same component, i.e. ones with the same ID. This is not always the case, doesn't always have to be the case. By controlling the object and component IDs together or individually, it allows us to implement different communication models as well. So for example, an instance could be assigned a fixed ID at design time, creating a service which messages from other various components are exchanged in like a client server arrangement. And this is done by a number of, is used by a number of Ubik systems. Or for example, you could have two network components on the same game object talking asymmetrically by addressing each other's component ID. So what actually goes into the message is completely dynamic at runtime. It's entirely up to you as the user. So this breakdown of the IDs into two parts is probably one of the hardest bits of Ubik design to get your head around. And you know, we're still trying to find the most intuitive way to represent this, both in the documentation and in the API design itself. But the different communication models supported by it and the ability for the user code not to have to worry about ID sync, even though they're coding at a very low level, actually dealing with messages themselves, does turn out to be quite important to the various services we've created. And we've certainly not been able to find a better model so far. So I did mention previously that we do expect the majority of use cases to use the room system and server. The main purpose of the room system is to facilitate rendezvous over the public internet. So Ubik is logically peer-to-peer, but there is no way to do discovery over the public internet nowadays. There just isn't, right? In every supposed peer-to-peer system, there's some sort of tracker or some sort of pre-shared secret that you use to rendezvous. And in Ubik's case, that secret is the server. So when a Ubik application starts up, at least in our samples, the network scene makes a connection firstly to the server. And at the other end of the connection is the room server, which is another Ubik component. So by this point, as soon as the connection is created, we are using Ubik's messaging system. So everything now for the rooms and the actual server is actually running on top of what's effectively a peer group that has just been created by creating that initial connection. And what the room client can do is it can negotiate with your with the room server running in this, if you like, sandboxed peer group here. So this is like a peer group. This is a peer group I want to join. And what it's going to do, it's going to communicate with this object. And when it negotiates for membership, the server will start to forward messages between all the peers in the room. So effectively, we kind of grow the peer group to include all the peers in the room. So yeah, so but another way, in short, when the client starts, it forms a peer group with the server, and then the server sandboxes that peer group until you negotiate with membership, and then it acts as a hub. And what this allows us to do is for one server to support a number of rooms, a number of applications, a number of different peer groups. And that's simply so that we can support multiple experiments or teaching groups, but only having to maintain one server. So in terms of more details about how this works, in terms of joining rooms, each room on the server is quite straightforward. Each room is identified by a GUID. Each room is basically just a list of peers, because all it is basically if you like, a broadcast relay group for the connections that are made to the server. So each of these has a GUID. Clients can join these rooms or peer groups in two ways. They can use join codes, which are short 3-character user-friendly codes generated by the server. And these are intended to be used interactively. So users would share these outer bands, say student groups would share these outer band, and they are used to join an existing room. Alternatively, room clients can create or join rooms by GUID directly. And this latter option allows us to do some interesting things. So for example, you can create a build that automatically joins a predefined room, for example, a particular build for an experiment, without having to risk collisions where experimenters have to name their own rooms or join using secrets which they code by hand. In scalability tests, we use these V5 GUIDs to create new rooms procedurally as users moved around a very large space. So users were moved into different cells, which were defined with a fixed point to the origin shared by everyone. And users in the same cell would actually end up joining the same room, all without any information having to be explicitly communicated, either between users or from any particular authority. And another example can be seen in the client you joined today. So a small script running on each of your clients that we created for this tutorial joined a predefined lobby room, so a prefixed GUID defined design time. Then what it did, it monitored the number of peers in the room. And when the number of peers reached a certain number, all of those users jumped to the same breakout room automatically based on a deterministic function that used the identities of the peers in the room to create a new GUID. Again, all without any explicit communication either between users or with an authority. And then we can get the join codes from the server in order to join for one of us to join each breakout group to have a chat. The server itself is written in JavaScript for Node.js, and the course is provided in full. And the motivation for using this technology stack is that it is very mature and it makes deploying a new server very easy. So it's very important to us that it's not just possible, but that it is practical and easy to quickly create entirely local deployments of Ubik, either for a group or even a particular experiment. So not just the room system, but also all the other services that are possibly server-centric, like, for example, stun and turn for WebRTC. The room client protocol isn't very complex, however, so other server implementations can be created on other environments. For example, the local loopback scene, one of the two primary sample scenes we provide, that actually creates a cut down server for testing written in C# that runs entirely within one Unity component and just sits in the scene. So if you want to do local loopback without talking to an external server, you can do that. So really the only thing that distinguishes the server from any other peer or network component is that it has this dynamically controlled forwarding ability. And of course, as Anthony mentioned, we do make our development server publicly available. It is called Nexus, and it is the default in all the samples, and you're welcome to use that for as long as you like. So that concludes the kind of the core Ubiq discussion. So messaging, architecture, addressing peer groups, and rendezvous. So for the next part, I'll go through some of the systems included with Ubiq that enable social VR. So Ubiq does include an avatar system, as mentioned. The default avatars are these 3-point tracked stylized avatars you see in most of the static materials. The avatar management system in Ubiq mostly just instantiates prefabs and advertises the avatar. Tracking and almost everything else is done inside the actual avatar prefabs themselves. So it is just as straightforward to use, say, photorealistic avatars as any other. And we do have samples showing how to use the Microsoft Rocketbox avatars, for example, with the stylized avatars or any other, if you're so interested. Avatars do have social features attached to them by default. These include speech indicators, user configurable names, and avatars can be customized. But again, this is implemented in the avatar itself. So our sample avatars support changing to a number of predefined textures, for example, but you could implement code on variants of these, or even an entirely new avatar. So voice chat is supported by WebRTC. WebRTC is the technology that underlies real-time communication in all modern browsers. And WebRTC was chosen mainly because it is the only real option for real-time communication in browsers, and so necessary to support our cross-platform ambitions. WebRTC is now an official IETF standard that's based on a number of other technologies and protocols. For example, negotiation is performed using SIP. The peer-to-peer connections are performed using ICE, which is standardized. Most software that uses WebRTC, and if you look in most, especially supposedly free or starting free frameworks for Unity, which are for networking and which do supposedly include voice chat, almost all of them will use this, even if they don't declare it. But if you dig down enough, you'll see that it's pretty much this technology stack that's in use. Most of them use libraries, use a build of a library maintained by the Chromium project. This is the one that actually goes into Chromium. I think Edge as well, as it's based on Chromium now. We use a C# implementation of WebRTC embedded directly into our package. And the reason for this is that it allows us to target all the same platforms as Unity without having to maintain native binaries. And it also allows us much more easily to use Unity's audio system to do things like spatialization and to allow the user to do other things using Unity's audio system. Whereas the Chromium library, the one that many people or many of the WebRTC server-side services, if you want to use those, they'll handle the entire audio stack itself directly. There is a downside to that though, and it is that using Unity's audio stack does result in slightly higher latency than using the native library. On the web, we actually use a browser's implementation though, basically by creating shims that call the WebRTC APIs directly using in JavaScript. And then again, this again is by necessity because the browser is a sandbox. There's certain things we can do for other platforms which you can't do in the browser without using up some of its supported APIs. On the experiment and development side, Ubiq has a complete system for logging user events intended to support both debugging and user experiments. So users can raise events just like they would in other systems, for example, just by calling a method like debug.log, like you would in Unity. Ubiq will forward and relay these events from all peers, most likely to a single machine that the experimenter is running for collection and later analysis. All log events are serialized as JSON, either structured logs, with the intent that it's easy to ingest them into another tool like a MATLAB or say a Python Pandas environment. As you can imagine, logging could introduce significant overheads. We do structure the code carefully so that only when logs are actually written do they invoke the serialization overhead or any other such handling overhead, and they don't generate garbage in the managed environment. So the idea is that it should be a low-risk system to use. If you want to place debugging calls throughout your code, you can place them there and you can leave them there and just disable the logging level when you're not using them. And again, the idea is that your diagnostic code, your debugging code, and your actual experiment code uses the same system so that you can, perhaps even after the fact, debug what's gone on in your networked application that your participants are actually using either during use or afterwards. And finally, Ubiq includes a component to spawn objects at runtime and to scope these to different levels. Objects can be linked to an individual user or an individual room, for example, and destroyed when these entities go out of scope. This is implemented quite simply via a catalog, which the user populates in the Unity editor, and then that itself is an asset which is maintained in the Unity editor and then can be loaded at runtime. In Ubiq, the network scene and the Unity scene are conceptually quite different. And this is a pretty important point that I've kind of touched on previously when I talked about how the network scene is actually implemented. So the network scene instance persists between different Unity scene loads by default. So it uses the don't destroy and load with the expectation that Unity scenes may be added additively, which Unity seems to be pushing, or completely replaced, all will appear as a member of a single room. And the various use cases you can imagine for this are, say, if you had a peer group that you wanted to move through different environments together, or say subsets of a peer group needed to have different views of the same environment. And this was used to great effect, as Anthony said earlier, by the 2-scale maze team, who actually created 2 different rooms at different scales, but the state of the equivalent objects was synchronized. So you could actually shrink down, go into the maze while your teammates manipulate it from above, and you could actually interact with, talk to, and wave to the avatars at completely different scales. You could see the little ones moving around, and you could look up and see the giant avatars above you. And Ubiq, of course, has a component to allow synchronized changing of the scenes. So currently, as I said, the network scene persists using the don't destroy and load functionality. We are constantly reevaluating this, though, as Unity does seem to be trying to get everyone to move away from this mechanism. So those are some of the main systems provided by Ubiq for social VR. And you can see how all of these work together in our Hello World scene, which is a sample that we would expect people to hack on, and is itself a completely fully functioning social VR application. So it shows off all these systems interacting with each other, and you can use that to join, meet up, change your avatar properties, chat, and even interact with objects that spawn other objects. So I will end now just by talking about a few general things that I think are interesting to note before we go for our quick break, and then hopefully onto something more interactive. Okay, so one of the last things I want to directly address is security, which is a pretty important topic for any network system. Ubiq operates by design in a high trust environment. So we assume everything in Ubiq is trusted. The other peers are trustworthy, the connections between them are secure, and the user code is benevolent. We do error checking, but this is not to provide security as such, but mainly to prevent mistakes taking out a process and limiting the effects should this happen. And you can see this evidenced by the fact that most of the error checking code is in the server itself, where the impact will be biggest if it were to go down due to a accidentally malformed message or similar. We've taken this approach for a number of reasons. The first, most important, is that security is hard, right? We're not a cybersecurity group, and to write secure software is basically a whole project in itself. Many use cases don't need the overhead of a secure system. One's running entirely in one lab. And this overhead that I'm talking about, it doesn't just occur in the use of compute resources, but also in the understandability and deployment complexity. And you can see this in the one place we do have to address security directly, and that is the use of WebSockets in the browser. So we do a browser client. We have a both native browser client and we have a Webxr, experimental Webxr client. So two clients run in the browsers. Modern browsers won't make WebSocket connections to unsigned servers, which means that anyone who wants to run their own server and use Ubik in a browser needs to generate a certificate. Now, right now, our server itself doesn't actually create a secure WebSocket server in itself. So the browser connections to Nexus are forwarded through a proxy, though we will get this functionality into the server as an option. But whether you're running it via proxy or whether you're actually generating and configuring a certificate for the server, you obviously need to know a fair bit about how these systems work to pull that off. And even more if you want to actually kind of interrogate the traffic running that has been encrypted this way, say with something like Wireshark. So this is one of a small, it is a small but significant set of examples just of the environment and the technology that we choose to operate in, introducing some very hard real constraints that we do have to work around. So one thing I expect we might get a few questions about as well is data persistence. So there are a few things in a social VR system that you can imagine should be stored semi-permanently. Things like user details, like usernames, avatar skins, so on and so forth. Say spawned object locations or other properties, room metadata, that sort of thing. So I did say that Ubik can spawn objects, and it does have some persistent data. And currently that is scoped at most to the room level. And rooms by default on the server, they do hold data and they are destroyed when the last member leaves. So that is the most permanent data in Ubik has the lifetime of an individual room. And the reason for this is that if we stored anything longer than that, we would have to start making decisions about, first it's stored in memory, and then it gets written to disk, presumably. At what point does that happen? What happens when the server process restarts? Do we have limits on what users can upload? How long do we store that data? So on and so forth. Basically, you start reinventing databases, which is something we do not want to do. So our plan at the moment is to support more permanent data by trying to effectively introduce a Ubikified wrapper around an off-the-shelf database or service. So basically to try and make an API that's very complementary to how our existing code works and how you would imagine you might want to build, social VR systems, how a naive student would think about how to access data and how it would persist. But behind the scenes, it's almost entirely outsourced to something that is easy to get started as our server itself. So that's as far as we've got with the persistent data so far, but just to highlight it for maybe further discussion if anyone has any thoughts. As I said at the start, Ubik is a Unity package concerned with the social and networking aspects of distributed VR systems. So our samples are meant to show how the various social and network focused subsystems can interact to create a complete social VR platform. And we also provide boilerplate code for common distributed experiment features like logging. Part of making these samples work is having a complete stack that supports everything from the initial connection creation to input processing though. So we have had to add some convenience features to make this happen while also keeping the example code as clean as possible so it's readable. So really, some of these systems, the APIs are written not so much for them to be functional, but to make the other code as easy as possible to understand when you're reading it. So an example of one of these systems is the player controller prefab. We do provide a player controller prefab. It has components that allow both desktop and VR controller input to work in parallel. And the idea is that you can drop the exact same prefab into different scenes, and without any configuration changes, you can make a build that will work on both platforms, both in the Quest, for example, and both are on a desktop. We also have a very thin action-based XR interaction framework that we use to support the samples. These really are only meant to do the bare minimum needed to support the samples. However, they aren't intended to be replacements for a proper framework like Unity's XR interaction toolkit or something similar like VRTK if you wanted to use that. So they are safe to use, they are debugged, but they're not intended to support all niche use cases like our primary code base is designed to be extensible to support niche use cases. So it should hopefully be fairly obvious which are the real systems and which are just part of the samples. And again, the whole idea is that you can use these or not. If you were to use something like VRTK, hopefully we've written the Ubik APIs such that it's very easy to use that with our package. And the last thing I want to highlight is our experimental support for Webxr. So Ben's going to say more about this in the next session, but the short version is that we do support Webxr through cross-compilation in Unity, and Ubik does work in the browser in both an XR and non-XR based context. So with Ubik, a user using a desktop executable build can talk to an experimenter running in the Unity editor, can talk to someone in a web browser outside XR, can talk to someone in a Quest. And this cross-platform interoperability is very important to us, not just because we want to support research into the actual experience of using cross-platform mixed reality, but also to provide as many options as possible for deploying experiments. So with Webxr builds, deploying a distributed experiment could be as simple as just giving a participant a URL, and with the ability to do things like procedurally create and join rooms, the instructions hopefully to the participant could be as simple as follow it. So that's hopefully my not too intense tour of Ubik. I hope that's given you a fair impression of what we're trying to do and what its capabilities are at the moment. So after the break, we'll move on to our interactive sessions. But until then, thanks a lot for listening. And I think we're good to take questions for a bit. So I'll hand back to Anthony.
Yes, questions, please. Anthony, you're muted.
You thought I was new to this being on Zoom thing. Yes, I'll just leave this here just in case anybody joins while we're not talking. If anybody's got any questions, join. For those of you who've been joined since we started, we had a bit of a flurry at the beginning where you could join a demo of Ubik. And I don't know if anybody's in there at the moment, but if you wanted to look at Discord, you can find the links to where to try it. And hopefully now it's a little clearer what was happening there. The server at Nexus is both the server, the room server, and also the web server for the client. And yes, as Sebastian's also mentioned, there's lots of things going on under the hood that allow you to build your experiments. So we'll answer questions now here or on Discord. Have there been any on Discord?
Oh, Kyle Johnson has one.
Can you talk a little bit about joining, leaving, and persistence and ownership? Sebastian, do you want to do that?
Yes. Hey, thanks. So one of the things which I glossed over a little bit is exactly where you store the data, the persistent data. So that's because this is one of the things that we are reevaluating to think what's the easiest way and most maintainable way to do this. But in short, you can attach data to an individual room in the form of a dictionary. So you can attach arbitrary JSON objects, for example, to a room. And Ubiq does include a dedicated component or dedicated system to spawn objects. And when you spawn those, you can specify the scope to which they exist. So for example, if you had something like, you know, a bullet or a laser pulse in a game, you probably don't want that to persist beyond the people who get the message. So as again, peer-to-peer system. So I spawn an object, I send a message around to everyone through the object spawning system to say instantiate this prefab or create this object some other way. Now, if I miss that message and it's a short-lived object, it probably doesn't matter. However, some objects you'll probably want to make sure that all new joiners receive them as well. So for those objects that are scoped slightly higher, either to a user or to a room, those go into the dictionary, and effectively the object management system will keep track of which users are joined when an object scoped to a user is created and that user leaves. The object management system will know that, it'll destroy that object. And of course, if you leave a room, any objects attached to that room will also be destroyed. So I said the rooms exist as long as there is a user in it. So I could, for example, join a room. I could create an object, scope to the room, someone else could join the room, I could leave the room, and then we can kind of go in this kind of chain where people keep joining the room and my object will persist. But at the moment the last person in that room leaves, that room is gone, all the metadata is gone, and so is the object.
We have another question, probably also for you, Sebastian.
Thank you.
How is this different and its advantage over the Unity multiplayer netcode?
So I did say Ubiq is fairly low level. So at the messaging layer, Ubiq does kind of sit around the same level as many messaging libraries for Unity. But what we add on top of that through the various subsystems and through our samples is basically all the social and networking that you would expect to build a fully functional social VR application. So typically you can kind of group these various libraries. So you have packages like Photon, Unity ML. I don't know if it's still going. I will say, just in case anyone hasn't looked into this too much in Unity, last time I checked, which was a couple of months ago, doesn't have inbuilt networking like Unreal does. So Unity did have networking, then it went away, and I think they're bringing it back in the new one. But there are a number of open source packages for Unity. But typically these will support Unity component synchronization, and some of them support voice chat as well. What you would need to do if you were to start out with one of those to get to the point of building a distributed application is you would have to add things like avatar, object spawn, you'd have to have logging. So that is one major way that Ubiq differs. It implements a lot of the functionality for you beyond just the message passing. The other thing it does, which is suitable for research, is that Unity multiplayer, I'm not 100% sure which of the Unity netcode ones you're referring to. If someone wants to post links of others, I can say more detail. But many different ones, examples of these systems, they will be written with a particular architecture in mind. So many of them use client-server based systems. And one of the ways they monetize, which is one of the challenges for researchers, is that the server, you can get the client code for free, but you buy tokens to use the server and they control the server code, which introduces various different difficulties. So yes, the main difference is that we introduce more services, and the other one is that many of these message passing libraries are written to assume a particular architecture or a particular way of communicating, which for most applications will be fine. As I say, we use a client server, we use the rooms server system. But if you want to do networking research, if you want to mess with architectures, there are some projects that will bump up against those, and Ubiq allows you to change that without breaking everything else. So those are the main differences.
Thank you, Anthony. Oh yeah, okay, I guess.
Oh, they have a
that's the
package.
best.
Cool.
Yeah, just to say, somebody asked about the 2-scale maze. The source code for that is on our website, and it was made available by the students after they finished the coursework.
Yeah, and
so we have updated it to the current build of Ubik because it has actually changed quite a lot in the last 12 months since last 12 months.
And I should point out that the 2-scale maze is one of my favorite examples. It's a really good example of where the constraints can be introduced by a higher level package. Because if you go at a higher level, if you want to do decoration and checkboxes, for example, many platforms may do things like assume that a Unity scene is the same as a room is the same as a membership, which would make doing things like having 2 different Unity scenes join the same room and having 2 different prefabs talk as if they were the same one actually very challenging. And this is why it's important to keep that low level access all the way through.
Okay, I think we could keep talking for another 10 minutes, but maybe we do all deserve a break until Ben starts. So maybe we keep it on the chat for a while. As I say, there's lots of us here, so if you want to post things on Discord or in chat, we can connect. If you want to have a discussion, if you wanted to connect with somebody on Discord and launch Ubik and have a chat in there, that would be completely possible, for example. So should we just pause there for 10 minutes, and then we'll resume with the more hands-on tutorial at 10. And we look forward to seeing you if you're sold. That was the marketing bit. Now it's the getting the hands dirty bit after the break. Thanks. Hello. So that went quickly. The break.
When did it work? Did it work?
Hi, can you see this? Clara, are you
Yes.
asking me if you can? Yeah. So this is my stream now.
Did the presenter thing work?
I think so. Yeah.
Okay. Right. So yeah, Ben, take it away. Yep.
Okay, so hello and welcome back to the next session of this workshop on Ubik. So my name is Ben. I'm an RA in the graphics group and an original member of the Ubik team. This talk will be on building your first application with Ubik. Sebastian and Anthony introduced you to Ubik a little earlier on. We'll recap very quickly and then get started with making things. So this is the recap. Ubik is a software library written primarily for Unity that implements the social and networking aspects of a virtual reality application. That is, it's a toolkit for building social VR. It takes the form of a set of components, prefabs, and samples and supporting materials. It's a package that's focused on social and networking features, which is meant to work with other packages to build a complete app. So Ubik is intentionally a library that's meant to work with other first and second party packages. It's not an environment, it's not a framework like VR Toolkit, it's not a platform like Roblox or like Meta Horizons. Rather, it's a package concerned with networking. It's meant to be used alongside other packages. So to put it another way, Ubik implements the features required by social VR for you, but you're also free to replace or amend them as suits the application that you have in mind. So today we'll try and use a subset of these features on the left. For this talk, we'll start from the very beginning of a new project. So we'll use a fresh Unity project. We'll load the Ubik package and get a sense of the built-in functionality. And then we'll look at extending that functionality with some network objects of our own. If you'd like to follow along, you'll need Unity as a starting point. For the purposes of this tutorial, we'll be using version 2019.4. We linked some more information on Discord with the assets packages that you might need. I can paste them in as a link into Zoom as well when we get going. But we'll go through the rest together once you have Unity. But if you'd prefer just to watch rather than follow along, but still want to see what we're working on, there's a completed example project available too, also on Discord, and also I'll post the link here. Okay, so if you have any questions while we're going, I've saved questions to Discord here, but you can also use the chat window in Zoom. Okay, so I'll briefly stop sharing this and share my desktop. Okay, so here we are. Let's start with a fresh Unity 2019 project. So we'll go to Unity Hub. We'll create a new project, 2019.4, and we'll call it Ubik tutorial. So while that is setting itself up, we will go to GitHub and we'll download the latest release of Ubik. So this is our GitHub page. You can see we have documentation here as well. We'll just go to releases and we'll download the latest package. So this is a Unity package designed to work with the Unity package manager. So let's download this. And also .package to distinguish it from the source code, because we'll also download the source code now. Okay, so now our Unity project has set itself up in the background. We're going to extract this package straight into the packages folder of this new project. And we will make a new folder called Ubik and extract into there. Okay, and while we're doing this, we'll also extract out the source code that we just downloaded to use a little later. So the reason that we extract into the packages folder like this is because this version of Ubik is designed to work as a Unity package with the Unity package manager. So the main advantages of that are that it can have dependencies, and then Unity will automatically resolve those dependencies on its own, and we don't need to sort of massively bloat our Ubik package size. Okay, so that's now extracted. We can go back to this Unity project and it will import everything and resolve the packages on its own. So once this is finished importing, we will go to the Unity package manager and we're going to import these samples for our Ubik, the sort of default Ubik samples. So we've selected this little drop down here, we selected in project, which is because we've already extracted out to the packages folder. So we can see Ubik is here. We'll import it into project. And this will be another import step while the Ubik samples get imported. So as Sebastian mentioned, these are hopefully a fairly rich set of samples. We have the sort of fully functional social VR app for you to try, which is what we'll start with because it's a decent place to sort of start hacking on things and come up with an application that's already starting from a fairly advanced point. So some of the nice things about that social VR package, oh, hold on, it's ready. So we will just go straight to it. Okay, so this is our Hello World scene. It's and the path is samples intro Hello World. So it's probably familiar to what you might have seen if you joined us in the web app. It's basically the same application, and it has all the sort of functionality that's. I'm going to make this a bit smaller so I can get to the play mode button. All of the functionality that will be familiar to you from that. So you can, I'll press play and we can have a quick look at what it has. So you can hold right click to look around. You can select these buttons and interact with them just by clicking on them. And you have some sort of interactables in the scene that work with our player prefab and our interaction mechanisms. So what I'm going to do first is I will join a new room. So what this control panel that's in front of you, it's used to join a room to find and play with other players. Rooms work very much how you might expect from other multiplayer experiences. So when connected, participants would be able to see and speak to one another. In the background, this is because peers in a room together form a peer group and can share messages across the Ubik messaging layer. I've also been given an avatar. You can see this just from my hand here, but also in the scene view, I can zoom in and I got some kind of cool zombie. So I'll join a room, but you might not notice any differences. And that's probably because I'm the only one in this room and there's no one here to see my avatar and there's no other avatars to load. So testing networked applications can be difficult because you want to find other users. So what we'll do is we will create an extra user. And Ubik provides a few different ways of doing this, but we're going to use the default and most obvious way that usually we'll avoid, but hopefully here it's it's demonstrative. So what we'll do is we will build a new desktop application. Let's call it Ubik Desktop. Okay, so while this scene is building, let's also have a quick look at, oh no, perhaps this is already finished. Yes, okay. Okay, so we'll just start at this application. Cool. So in this little window, we are Noble Cat. And if we press play here, then we are once again Brave Hedgehog the zombie. So with Brave Hedgehog, we will join a new room. We see that room is JRG. So if we look around, no avatar, we'll join JRG. Okay, and we have Brave Hedgehog here and me, Noble Cat. And you can see that the WebRTC audio stack has connected, and we can now talk to one another. There's this voice over IP indicator here, which shows that the audio is being received, and it visualizes, when that happens. So there'll be a lot of latency on this, but I will just quickly test. Okay. Let's see, next steps. We'll remove that that client, and we can see that his avatar disappears. And we will stop playing here. So how this was able to be possible is that at the moment that we pressed start in either of those apps, the moment that either app started, it was connected to our server at Nexus, which is by default configured to be automatically connected to. So we provide Nexus publicly, and you are definitely welcome to use it for as long as you like and as much as you like. But you're also free to use your own servers, and that might be something that's required so that you keep all your data if you need to be GDPR compliant, for example. So that's also quite an easy thing to do. We downloaded that the Ubik source code. So I want to quickly show you what the server is and start one up locally. Okay, so we've browsed to the node folder in the Ubik source code. This is the entirety of the server source code. Most of the work is done by the room server. As Sebastian mentioned, we have this JavaScript Node.js implementation of that, and we also have a simple C# implementation of it too. So it's a relatively simple protocol. We also have this folder here, which is the Ubiq library, and that can be used for Ubiq operations in the browser, for example. So what we'll do is I'll start up a terminal window, and I'll navigate to this path. And then I'll use Node to install the packages required, the dependencies that we have for the Ubik server. Okay, so dependencies installed, and then I can start the app simply with node app.js. And you can see that we've added room server listeners on port 8005 and 8006. 8005 is our TCP listener, and 8006 is our WebSocket listener. So if we go back here, so currently this will still connect to Nexus. We can change that to connect to our local version, and then we click play. And we've connected. So now we're on our local server instead. I'll make a new room quickly. And if we go over to our terminal now, we can see that this new client's connected, and they've joined this room with join code Z50. So yeah, join code Z50. Okay, so let's explore what's in this scene a little before we move on. We have the network scene, which you've already seen has this room client. This is a very important class in Ubik and is required. You can have at least one network scene, you can have more, and components will find the closest one and will send messages to that network scene. The network scene will pass things back, will fan out messages to it. So it's the network scene that's responsible for the multicast behavior in Ubik, and it's responsible for routing messages to objects with the correct IDs. The classes that it routes to include this room client. So the room client is really just a regular Ubik object, which will receive messages from its closest network scene. And the room client is the portion of Ubik that communicates with that room server that we were looking at. That's part of the server. So other important things, we have this player prefab. So the player prefab is as Sebastian mentioned, it's kind of a convenience more than anything else. So we have the capability to do all sorts of things like control with XR and control with desktop, and do both simultaneously. So you can, for example, move your XR origin around the scene while also in an XR session, which is often quite useful for debugging. But the player prefab isn't, as I say, entirely optional. So it's not connected with networking in any way. And the only way that avatars work out where they should be is with this one little class here, the position rotation, the avatar hint position rotation scripts, which tell avatars where they should be, and you can put those on anything. So it's totally okay to use player prefabs that come from things like Unity's XR interaction toolkit or Microsoft's mixed reality toolkit, say. So Unity's Ubik is definitely designed to integrate with those things. Okay, any other things in this scene that might be worth looking at? The environment is entirely static, so that will help us to not network it, but that will become important later. So I think we've gone over the basics of what Ubik provides out of the box. I think it's probably about time that we started to look at extending it. But for the moment, we're going to go back to the slides and describe some networking concepts, some things you might need to know before we start making networking objects. Otherwise, their behavior might seem a little baffling. So this would be a good time. If anybody's wanting to follow along but having trouble getting to this point, please let us know on Discord or chat. And we should be able to get back to you and help while I'm going over these slides. Okay. So some concepts from networked VR, but also just in general networked applications. To create your own applications, you need to know a few basic concepts that are common to all networked VR systems. These are things to do with synchronization and message passing. Synchronization is really the absolute key topic here. So say you have an application running on one computer, even if that application is multi-user, then sharing that experience is very simple because there's just one copy of it. It's a regular game that just processes multiple inputs. Nothing needs to be synchronized because only a single copy ever exists. But let's start developing this out into the concept of a networked game. So let's say that we were playing a game of basketball. In memory, I have a ball, I have a score counter, and an idea of where I am in space, so position. When we try to extend this idea of the world across multiple machines, we introduce the problem of synchronization. That is, my PC has a version of the world, its own Unity process, let's say, working with Unity, and so do the other players. So you have these multiple copies of the world out there. They need these copies because each individual machine needs to drive its own display and input devices. Though there is such a thing as remote rendering, it's very specialized and is not really relevant to building practical networked VR or general networked applications as we do right now. So in order to play the game with each other, all players must have the same perception of the world, and so it needs to look the same on each machine, or at least close enough. If machines aren't synchronized, then over time the state of different machines would diverge, and we would no longer be playing the same game or be able to cooperate effectively. So the position of the ball would be inconsistent, for example, among multiple users. Keeping copies synchronized is the primary job of a networking library. The library sends messages between each process so they maintain a consistent state. In Ubik, individual scene objects send messages to each other directly. For example, if I have a basketball and one user throws the ball, in Ubik, the ball is a networked object and it sends messages telling the other copies of itself at other machines what its state is. The task of network developers with Ubik is to implement networked objects, i.e. to decide what should be shared and what should not. For example, what if I made the ball bright red? Would that be important to share? Maybe, maybe not. If there was a crowd, would it be important to share all the positions of that crowd? Probably not, but it might be important to share when they were cheering, for example. There's no single answer and it depends entirely on the application. So Ubik will handle sending messages between objects, but it's for the developer to decide which object should send messages, make those messages, and tell Ubik to send them. This is something of a recap. In Ubik, Unity component instances can be given an ID. When messages are sent to this ID, they're received by all other instances with that ID. This ID is like an address. So if I was implementing my basketball, I might give it the ID 1001 and tell it to transmit its position every frame. If I have 3 players, when one sends an update to 1001, it's received by both others. That is, the network fans out the message. You don't need to know how many copies there are or which computers they are on. You can have multiple copies on one computer or 1 copy per computer. But you do need the common address of the copies. We can hard code that for very simple things, but likely you'll want to use another mechanism which will ensure the objects have the same IDs on all peers. So Ubik provides an object spawner class for this. We will be hard coding them in the example today. In Ubik, each peer has a network scene. This is like the networking equivalent of the root. Components register with this, then hand messages to it, and it will send messages across the underlying network connections. So you've seen this from the samples when we looked at it previously. So the main thing to remember is that that network scene is the thing that fans out these messages to the objects with correct IDs. Okay, so time to get back into it and we will make our own application. I'm going to take a quick moment here to link the assets that we need in the chat for Zoom as well as in Discord. I'll take this from here. Okay, just so everyone can follow along if they want to. And okay, so back to Unity. The first thing we're going to do is import that tutorial package that I have linked. So I have an already downloaded version of it. You can just import it to the... Oh, right, yes, sorry. Okay, right. Yeah, so back to Unity. I've linked that tutorial package and I've imported it here, which you viewers will have missed, but I just imported that tutorial package to the top level of this Unity project. So let's start with the hello world scene that we've already seen. Okay, so we're already here. So there's a prefab here with an environment in it. We mentioned previously that this environment is entirely static, so we're just going to disable that momentarily. We're going to drop in this new environment. And you can see now we have a new environment to be in. If we press play, we can run around in that environment in the way that we would expect. Okay, so like the previous environment, this new environment is entirely static with no scripts. But we are going to create some. So let's make a ball. I'll make a small sphere, we'll half that size. And we'll put it somewhere convenient. Okay, and we're going to make it, just for convenience, a child of the environment. We're going to call it ball. And we'll create a new script. Ball.cs. Okay, we'll open ball in code editor. So I'm using Visual Studio Code, but Visual Studio is also very good. So the first thing we're going to do is implement the iGraspable interface. This is part of those Ubik interaction mechanisms that, again, are optional. We're going to use them for this tutorial. We've used them for the rest of the samples. It may or may not be something you want to use, but it allows you to do simple cross-platform and cross-desktop and VR interaction. So we also need okay, and then here we'll implement all interface members explicitly. So we need to have new grasp and release functions. So when we're grasped by a hand, we'll just store the reference to that hand. Oh. Okay, and let's do an update on our position in the update function, which can move this object around if it's grasped. Okay, so we'll return to play mode and just test out this very, very simple interaction. Okay, so we have our ball. We will middle click on it, and then we can move it around a little. So this is implemented as middle click on desktop. In VR, you can just sort of reach out and grab it, so much more intuitive. But this control scheme works well for testing. So we can also move the object closer or further away to us, and we can release it. So now we've released it, the ball won't move with us anymore. This looks nice, but obviously this is not networked in any way. And if we were to have multiple scenes, multiple different clients, then the ball would move on one and not on the other, which is not what we want. So what we're going to do here is end play mode. We'll apply this override to the prefab. So now the ball is part of the environment. And we will move to a different scene. So this is one of Ubik's mechanisms for helping test social applications. So the idea is that if you use a local version of the server and then multiple network scenes in one scene, let's save that, then you can effectively test remote behavior, because those local versions of the network scene will be getting each message fanned out across them. So what we need to do here to make it behave like the other scene is we'll disable these environments. we'll pull in that prefab that we made, place it on each scene, on each forest. And this environment comes with directional light. So we'll just turn that off to get the normal lighting back. We'll also move forest to a bit further down. Okay. So now, if we press play, now you can see it's a little far away. I see. Okay, one moment. These have been swapped around. So let's send forest 1 to 0. Oh, and forest 2. We'll bring you a bit closer. Okay, so potentially I made an error with the origins, but the general principle remains the same. So we have this one scene here and another scene here. Okay. Right, yeah, got it. Okay, so now if we go into play mode, we've got these scenes in the correct positions. If you are following along, try not to do what I did. Don't change the origin of this environment. Let that stay at 0, 0, 0, and just move these forests instead. Okay, so now what we have is an avatar in this first version of the scene. In fact, no avatars in either version of the scene, or rather, okay. Again, these origins messed up. We have an avatar in this version of the scene, which is our local one. He can move around and he can grab the ball, move it. But the ball that he's moving is over here instead. So if we, at the moment, these local room clients, they're not connected to each other, they're not connected to anything. We can easily connect them up to the same room server, which is this C# room server here, which we've made to act like the remote server. We'll join them all up. And now we have an avatar in each room. We can see these avatars moving around. So in this case, the avatars are synced, but we can see once again that in this case, the ball is moving, but in this room it isn't. So the avatars are synced, but the ball is not. What this means is that we'll need to go and add some networked messages to our ball so that it acts like a networked object. So if we go back to our ball script, and we can now implement a few new interfaces to make the ball act like a networked object. So we'll start with network component. I'll make it a networked object too. So this difference between networked components and objects is something we've covered before. Networked objects are, have an ID, which means they are identified on the network. Networked components are something that can belong to a networked object and receive all the messages destined for them. It will have its own its own ID, which can be auto-generated. So we now have this ID. We're going to hard code this to 101. So in general, a static ID baked into a script like this is usually not good design. What this will mean is that all messages we send to any instance of a ball will go to every instance of it in the room. There's also the possibility of collisions with other objects because we've already made this, we've just written this into code and we haven't documented it anywhere that you shouldn't use 101,001 because it belongs to this ball. So we provide a spawner class that's capable of creating objects at runtime and assigning new random IDs, which is usually a much better approach. But for the purposes of this tutorial, the static ID will work because we know it's unique. So we'll add a network context. Now you can see that the network context will be how the network component speaks to the network scene. So the network component will be able to register with the network scene, and the network scene will know to send this network component things. So let's register in the start function, which is one of Unity's callbacks. Okay, so now this object is capable of sending and receiving messages, but it won't do anything on its own because we haven't told it what or when to send. So let's start with what to send. We will make start message. Message will be very simple and we'll just hold a position. So when the object is being held by a user, that user sends its updated position each frame to all peers. That won't happen yet, but it seems like a reasonable way of syncing this object between peers. So we'll go to update, and if grasped, then we'll assume that we are the authority on where our ball should be, that our local copy of the ball should be able to tell remote copies where they ought to be. So then oh, I see. Okay, there must be something I'm missing here.
It's the member in C#. As in the member position has to be public.
Oh, I see.
Yeah.
Oops.
C++ the other way around.
Yeah. Okay. Right, so now that compiles, and we can press play again. Let's have a quick look. Okay, so now if we pick up this ball, right, okay. Let's start that again. We'll go to our server. We'll connect all the room clients. We'll have an avatar in each room. We can walk over to the ball, pick it up. Oh. I see, okay. Apologies. So something we're missing in this script is the ball will still not move around. And we can actually see why this is happening, because when this, although we send messages, we never receive them anywhere. So this process message function is the callback from our network context, which tells us basically when we receive a message and what that message is. So we can receive that message. We already know what the message is because it's a struct message, and we can turn that. We can take that from JSON and turn it into back into a message. We can set our local position to message.position. So we're taking that remote position, we're setting our local position with it. So now if we click play, we'll join all the room clients. We have an avatar in each room. We can pick up the ball, move it around, and we can see that the ball is now being synced across the two. So it behaves like a network object should. Okay, so that's almost our time. There's one other thing I would like to show you, which is another method. You've seen local loopback, but I'd like to show you another method for testing your networked objects in Unity. So we will take this environment. Okay, that seems to work. We'll go to Hello World. Okay, and what we're going to look at is this mirroring behavior. So we can keep two Unity editors in sync using a simple Ubiq utility. So I've already created another project just for the sake of time. If we go to okay, I've done Ubik and Ubik Save and Mirror Project 2, selected this other folder with this other Unity project in it. And now I'll load that Unity project up. So we've also gone back to the Hello World scene here with the UI that we're familiar with too. So the purpose of this is if you wanted one user in VR, say, or wanted to test something that relied specifically on input. So we can see that now that sync has happened in the background, and we can go to samples, Ubik, samples, intro, Hello World. And now we have the same scene on both. So we can click play on one. Play on the other, they'll both connect to our scene. We do this is HBR, so we can join HBR on this one. And now we can have two avatars in this environment. In a moment, their voice will connect. And we can test our ball, move that around, and we can see that the ball's also being moved here. Okay, if we wanted to change something like make this ball a bit larger, or let's say very large. Now the ball is massive, and we can save that. We'll do save and mirror project. Unity will prompt us to reload the scene, and we have this massive ball here. So that's another way of testing your networked social applications. So that's everything from this portion of the workshop, how to build your first networked object with Ubik. Network programming is a very big topic, and there are syncing mechanisms in Ubik that we haven't had time to look at. But hopefully this gives you an idea of where to start building networked applications. Thank you.
Thanks, Ben. I've just put a note in the Discord if anybody would like to have a discussion about using it in teaching, then that's very much based on the first tutorial we gave our students this year, and we are happy to discuss how we follow up and how we get them using the system. So the next phase is the next 30 minutes. We've got a series of presentations about different features which are new and underway. So I don't have the running order. Who does?
I was starting.
Lisa, right? Very good, thanks.
But since I'm not a co-host, I cannot share my screen.
Yeah, you are now.
Thank you. Perfect, thanks. Yes, so thank you for having me. As Anthony mentioned, we're gonna talk for this last session of the tutorial about some features that are under working or already implemented in Ubik. Some of them are available on the GitHub. So please, if you have any question, we'll be able to answer them afterwards. I will just start the presentation with talking about how we support different avatars and avatar control tools for Ubik. So first of all, let me introduce the Microsoft Rocketbox avatars. That's an open source library that have been developed by Microsoft over the past few years and been used widely in the research area. It offers more than 100 avatars with different type of jobs, but also gender and races, which enable any type of different experiment and different avatars in your experiments. These avatars are fully rigged character and allows animation of both the body, but also the facial animation. Why we decided to use this Rocketbox avatar is that we wanted to offer another solution from the floating avatar that currently exist in the Ubik. So to be able to implement this Rocketbox avatar is quite easy under Ubik. Basically, you just have to follow the same implementation system as the current floating avatar that we're using, but with a bit of a twist, because you have to change, for example, the current avatar management script and avatar networking script. But just like our cartoony avatar over the network, we only send the information related to the head position and rotation, but also the hands position and rotations. Indeed, currently for fully rigged avatar, we use the solution Funnel IK, and most importantly, the VR toolkits. So this enables the users to embody fully the avatar and to be able to walk around into Unity. Also, for a fully open source solution, you can, instead of using Funnel IK, which is not open source, use the Movebox avatar toolkit. This is also a toolkit that has been developed by Microsoft, and that allow, more importantly, the head and also the hands animation. But for experience with avatar walking around the environment, Funnel IK have been used for the past month for our own experiments. Why we decided to have this Rocketbox avatar implemented in Ubik is that, as we presented Ubik as a social VR platform, we want to be able to offer a variety of different avatars to our users, and also for experimenters to be able to work on the role of avatar realism and also customization, and to be able to implement different type of mixed group of avatar for their experiments. Thus, in order to be able to work on the effect of user representation in social VR. So far, we've been working on trying to replicate different past studies that our group have been working on, mostly Anthony, back in the days. What have been a great result is that both the integration of realistic avatar and cartoony avatar and the Ubik enables some users to be either co-located or to be separated from like different rooms, even different countries, but still be able to collaborate and communicate in VR. And having these two different type of avatar have been for us a way to invest on the impacts of their realism on, for example, transformation or leadership. So it has been a great deal to have this avatar with us. Also, one important thing we have been working on is to try to think what kind of controls experimenters and researchers might want to have in Ubik. So for now, we have, for example, some controls regarding experimentation and scene management for experimenters. For example, we enabled experimenter to load different scenes to be able to time and run the experiment in an easier way. We also enable some tools for avatar controls for example, such as controlling their visibility, but also to control their voice. So this kind of features enable the experimenter to be able to have a time experiment where they will set the user, then try to give them instruction regarding an experiment, and then to just like let them run their experiment. What we would like to see in the future for the avatars in Ubik would be for experimenter to have more moderation control, so to be able to control what the user, not control what the user are doing, but to be sure that the user are being respectful of each other and be able to have control experiments. We also would like to implement user privacy controls such as bubble mechanism, which we can already use in a lot of commercialized social VR platform. And finally, having avatars such as Rocketbox avatar will be a solution for us to have more expressive avatar and to work on the evaluation of social cues. And to finish with, we would like to see more open source toolkit to be implemented in Ubik to have a fully open source solution for both experimenters and also our students. Thank you. I'll lead to Clara, but if you have any question regarding Ubik avatars and user representation, feel free to use Discord. Thank you.
Okay. Do you all see my screen? Okay, wonderful. So hello again, I'm Clara. I've been working on a record and replay feature because I'm working, like my PhD kind of involves working on learning interactions with virtual characters. And therefore, I created this feature in Ubik to capture training data from social interactions in virtual reality. But apart from data capture, the record and replay feature also provides a simple way to quickly populate scenes with characters, as it is possible to record and replay previous replays. And we have also used it as analysis tool for social interactions between users in VR. But how does it work? So let's say we have me as a local peer, and I'm represented by the blue avatar, and I'm in a room together with a remote peer who is represented by the yellow avatar. And the remote peer's avatar is also shown on my side, and my avatar is also shown on the remote peer's side. And like we've heard already, so then messages, including like my my avatar's position are sent from my avatar using the network scene to my avatar at the remote peer. And audio from my microphone input is sent over the peer-to-peer connection. The same, of course, applies to the remote peer, just the other way around. Now, recording a session works as follows. The recorder and replayer component intercepts incoming and outgoing network messages, buffers them, and writes them to binary files, like one file for avatar data, one file for the audio samples, and then some additional metadata file, which saves general information about the recording itself, like the objects recorded, texture information, object IDs, something like that. So basically this means that everything that is recorded, everything that is networked can also be recorded, which is cool. So once we got the recording, we want to initiate a replay. And so first, with the information in the metadata file, we just recreate the objects from our recording at the local and the remote peer. And then we need to change one thing, namely the object IDs of the messages, before we can actually replay. So initially, the messages were saved with the object IDs of my avatar and my remote peers. So the recorded messages would be sent to our avatars. But to let the created avatars receive these messages, we just have to replace the object IDs of the messages with the new object IDs of our newly created avatars. And then the messages just go to them. To replay audio, a Unity audio source is added to the replayed avatars. And the audio source is filled with the data from the audio file. And the remote replayed avatars simply receive the audio data via network messages that the local recorder and replayer component sends to its remote counterpart. And to show you how all of this works, I prepared a video that I recorded while being in VR. So you can see my fellow colleague here waving, and we just record something. We just dance a little and it's fun. And you can see that this is the basic record and replay UI, and we have a record button. We have a button to load the replay, and soon we'll also have a button to play the replay. So now we just change the position, load the replay, play it, and record again. Then we can continue dancing a little more. The recordings, they get added in a list below, the most recent one first, and from which you can later just select the files. Currently, the latest recording gets automatically set as the next replay, so it's just easier to do this in the video. Yeah, we do another recording, of course, because we want a big crowd, so it should be fun. And we dance a little. Yeah. Not the most skilled dancer. Okay, and one more. Yeah, freestyle. Okay. I hope the video kind of plays somewhat smooth. Okay, and now we're done. We enjoy the crowd with a little music. Oh, so happy. We can just. Yeah. Oh, it's lovely to watch. Well, that's it from my record and replay part. Thank you for your attention.
Thank you, Clara. So I just want to give a few thoughts on scalability next. So, and by scalability, what I'm talking about is user capacity. So the maximum number of users who can exchange social cues in a group, but also how many users we can support moving around a space, forming new groups to exchange social cues within. So this is a pretty important topic, and it's very important also to be able to experiment with it. Almost every social VR system out there supports a small group interaction, and beyond this, a smaller number have also experimented with broadcasting or presenter style context, what sociologists would call common focused interaction, say like Verbello or say like Holdspace with its broadcasting functionality. But the space of interactions, the social interactions that humans can engage in is much greater than this. And once you move outside really these two, a small group or presenter style, support falls off very quickly amongst pretty much every single platform. So on our part, we've had, so far, we've had one master's project look at scalability, and a paper from this is under review from their work. And to support this and follow-up experiments, we have created some fairly comprehensive systems in Ubik for stress testing. So I'll summarize what those experiments were from that master's project and the features that we've created for that and have developed since, which will of course be made fully available as part of Ubik. So to summarize what we know about capacity in Ubik so far, firstly, I should say all these tests were server focused, which we consider to be the first kind of bottleneck of the system so far, because this is what we expect the most common configuration to be. So capacity at the moment kind of hits two bottlenecks. One is on a peer-to-peer basis, is the audio system. All audio, even when you're using the server, is peer-to-peer. Each peer creates an audio connection to every other peer, and typically the user CPU will fall over depending on what platform this is, typically about 20 users. On the server, capacity is reached when the message rate exceeds the server's ability to fan out. And this depends primarily on the number of peers, but not just that, but also the update rate of each component within the peer, and of course the number of networked objects and their network rate. So it's actually the number of messages and the overhead of handling those. The actual size of the message doesn't matter that much. Neither does the number of connections. It's really just the number of messages and then multiplication factor. So if we were to look at the Hello World sample, if you want some hard figures, if we were to look at our Hello World sample, we would expect about 20 to 30 peers in a single room before we reach before the server is unable to keep up with that. And of course, the server can handle multiple rooms at that rate before we begin to see slowdown, and slowdown experienced by higher message latencies. So what the master's project looked at was spatial partitioning schemes for the server or rooms within the server. A student, Otto, a great student, tried two different schemes based on k-nearest neighbor approach and a hex grid approach for basically producing peer groups within a larger space. And they were enabled to improve capacity about fourfold. For example, you can see this is the hex grid approach. You take a single Unity scene, and this is partitioned into cells. And as users move through the space, they can form smaller peer groups by effectively turning each cell into an individual room. And obviously, there's a lot of nuance to these figures that I've just given, as the different optimization options you have to optimize for capacity are very application and both context dependent, because of course the number of messages exchanged and what type of messages you exchange will depend on social cues. How high the message frequency has to be depends on what you can kind of predict and that will depend on cue, whether it's eye gaze, whether it's voice, whether it's hand gestures, and the type of social interaction. Are you right next to somebody? Are you signaling across a room? So the challenge behind this really is that, especially for a system like Ubik, which wants to support, avoid prohibiting niche use cases, there is no real generic rule set that can be applied for optimizing scalability based on what we know about social interaction. We do have a number of techniques to explore this further in different ways, though. So we have a bot system, and this basically works by replacing the player controller in an individual room. So the bot itself will basically drive Ubik's functions as if it were a user driving the user interaction. Bots can join rooms, they can move around of their own accord, they can even generate audio and interact with both each other and actual peers joining the room to exercise the voice systems. They just play a tune and will receive audio as well. And we have infrastructure to manage large numbers of bots. So in Ubik, as I mentioned before, we can create multiple peers under one Unity scene. And this is very useful for stress testing, because a single Unity process can actually support support, as you can see in this case, about 20 bots. We can also have, of course, different peers to manage for these bots. Each bot is a peer itself, and we can have another peer in the environment to manage those bots across different processes. So in this, we can actually create builds of create a Unity build with a command and control room that it's set to auto join, and then you can spin up a number of these across one computer or multiple computers, and then you can then use that command and control room to send messages to command each process to generate sets of bots, and then tell them to go ahead and join a particular room on a particular server to test out different ways of managing different numbers of bots and different scalability techniques. So all this code is going to be made public. The only reason this is not in the main branch yet is because the test environments that were used for the master's project were not open source. They were paid for assets, so we need to swap those out with fully open source and redistributable assets. Once we've done that, we will put this in as part of core Ubik, and hopefully, if you're interested, you can use those to experiment with scalability techniques of your own. So in the future, as I say, we consider scalability very important, and we do want to build scalability features into Ubik to raise that 20 to 30 peer limit, but we have to do that in a way that is complementary to all the different ways that people might want to use the system. So the challenge is right now, there's no single solution for scalability that kind of goes infinitely. The spatial social interactions between people is not uniform or continuous, and the type of cues required does depend on the context. So there are taxonomies for this, and there are, in some ways, parts of this have been quantified, which offers us a number of opportunities. But of course, we're not assuming any particular type of interaction. So there's a lot of unknowns still before we can build anything into our system that maintains flexibility. But it is a very active and interesting area, and we do have features to look at it, at the very least, and perform some experiments around it. So if you want to talk to me about scalability, then please get in touch. It's a really interesting topic, and I'd be happy to chat more.
Are you ready, Ben?
Who's next?
You're still muted, Ben.
Okay, hi. So this is going to be welcome to this short session on Webxr support in Ubik. So Webxr support is something we've been working on in Ubik for a few months now, and it's still experimental but largely functional. The web app that we're sharing with you today is built with it. As it's been difficult to meet in person over the last few years, our group at UCL has run an increasing number of studies remotely. What we found is that finding participants is a real challenge and maybe the most time-consuming part of the whole process. There are many VR devices in the world now, so in theory, our participant pool would be large, but in practice, very popular devices like the Oculus Quest are walled gardens. There's little chance of getting a study app on the official store, so users are required to sideload apps, and the participant pool becomes just a small set of VR experts, which is not really what we're after. Among other benefits, we saw Webxr as a solution to that problem. So it runs in a browser, and that means we can benefit from web sandboxing, meaning we can run on the Quest without developer accounts or sideloading. So for desktop users, the barrier to entry is also a lot smaller, and there's less danger associated with just going to a link and running remotely than with downloading and running remotely downloaded executables. You can also easily spin up multiple copies of an app in browser tabs, which is great for testing and kind of fun. But there are a lot of additional factors to bear in mind when developing for Webxr, as it's still relatively new and the web can move slowly. Performance is often good, surprisingly good, but not at the level of native apps. So developers will need to avoid things like real-time shadows and that sort of thing. It's also only single-threaded, although things like the browser WebRTC implementations can use threads in the background, but actual app code has to be single-threaded, which meant when we were implementing it in Ubik, quite a few core Ubik systems had to change or have custom versions. The development tools are often also incomplete and can fail in unexpected ways, particularly at the interop level. And as you might expect, compatibility with web standards across browsers can be a real minefield. We hope to protect users from this in Ubik, primarily by providing all the browser interop code the user might need within the package, i.e. developing it ourselves, so users mostly don't have to deal with browser interop. So this is the build structure for our Webxr support. Input is provided by the Mozilla Webxr plugin for Unity. We provide our own HTML templates and interop code to link the Unity app with the browser in a way that's largely transparent to the developer. So building a web or desktop app with Ubik can be done with the same project and the same code. We'd always had a web version of Ubik in mind, so we've supported WebRTC from the very beginning. Our interop code connects the app to the browser's WebRTC stack, which allows us to benefit from fast implementations of encryption and Opus for voice over IP. We also use web audio for spatialization, which saves a little bit on performance, but also cuts down significantly on latency versus pulling things into Unity. But we do provide a method for pulling audio from web audio into Unity if the developer needs the raw samples for some reason, like for example, to hack on them and kind of find something interesting about clients. This is our network structure for the web app, which is available at Nexus, our server. So a simple static file server provides the application, which then talks to the Ubik server like any other app built with Ubik, and it's cross-compatible with those other platforms. We host both the file server and the Ubik server at Nexus, but this doesn't need to be the case, and any static web page provider could be used, including free providers like GitHub Pages. Okay, thanks for listening. If you want to talk about anything Webxr related, whether it's questions or just to share frustrations, if you have been working with it, then because I really know it can be frustrating, my email is on screen now, or please post in the Discord. So please also try out our Webxr social app for yourselves. The link is on screen. It's also in Discord. It's a bit of fun. Hopefully you'll be connected with somebody and able to chat with them. Okay, thank you.
Okay, cool. So thanks, Ben. Hi, everyone. My name is Nels Newman, also a PhD student at the VCG group. As you may have seen in this tutorial, Ubik has great capabilities for the creation of networked social VR experiences. I will now spend a few minutes on discussing how we can use Ubik in combination with mixed reality devices. Ubik does not rely on any specific XR interaction platform as mentioned, making it suitable for integration with different SDKs that are device specific. So for my research, I've implemented multiple mixed reality applications based on Ubik in combination with the SDKs that are listed on this slide. So Lumen SDK for the Magic Leap 1, MRTK for the Microsoft HoloLens, and Oculus integration for Meta Quest and its pass-through capability. So in this tutorial, there is not enough time to get into the device-specific setup and development instructions. Therefore, instead, I will go over some basic points to keep in mind when you're just getting into developing for mixed reality devices with Ubik. So Ubik is generally not restrictive in terms of configuration of Unity player settings or deployment settings. On the other hand, device-specific SDKs typically are. So for this reason, it's important to accurately follow the setup instructions of the SDKs to modify Ubik scenes and configuration. So a point you will often see discussed in these instructions is to how to set up your camera, which is especially essential for augmented reality devices. The Unity camera contained in Ubik's player prefab already handles stereoscopic rendering, follows your head movement and rotation. However, AR devices require specific camera settings regarding things such as depth buffers and clear flags. Making these changes is simply done by modifying the settings of the Unity camera nested in Ubik's player prefab, or as Ben mentioned earlier, just put an avatar hint on the camera rig provided by the SDK, which is maybe the easiest shortcut. But yeah, then you don't have all the avatar stuff already configured. So lastly, I want to highlight two considerations that are quite big to get into now, so I won't, but just to touch up on them. Firstly, when designing an AR experience, you have to answer the question of how objects will be anchored to the real world. And many SDKs provide solutions for this, which can be combined with Ubik's network capabilities to create a shared virtual experience. I will mention two solutions for this in the following slides. So lastly, it's important to consider how objects persist in the environment. The technical aspect of persistence can be solved by integrating Ubik with object persistence capabilities that many SDKs provide. But there's much more to consider, such as who owns the object and where do world-anchored objects go when one or all AR users leave. So I will now go over some findings regarding the integration of Ubik with SDKs of different devices. And in this, I will specifically focus on how to anchor virtual objects to the real world. Okay, so the first device I will talk about is the Magic Leap 1. And the Magic Leap 1 is a standalone device in terms of both computation and tracking. Development for this device can be done with the Lumen SDK. So after installing the Lumen SDK and tweaking the player settings, device permissions, scene configuration of the Ubik Hello World scene, the device is already ready to run Ubik. An example is visible here, where a Ubik avatar freely roams around our office space. So the Lumen SDK exposes a functionality referred to as persistent coordinate frames, PCF for short, which can be integrated with Ubik to create network world-anchored objects. And whenever the Magic Leap recognizes that it is in space it has seen before, anchor points are restored. And in this way, any objects that have been created previously can be restored relative to the nearest anchor. And in turn, these objects can be networked using Ubik, making it possible for other users to see the same objects under the same transformation. And for AR to VR collaboration, for instance, entire spaces can be aligned with each other, either manually or with fiducial markers. So here we see a simple network object tied to a visualized anchor point. When Magic Leap users touch the object with their hand controller, the objects are highlighted and the link to the bound PCF is shown with a line. So users can hold their trigger, for instance, on the Magic Leap to move and rotate the object around the space, which are then subsequently registered to the nearest PCF and are networked with Ubik. So another device that harmonizes well with Ubik is the HoloLens 2, which is another standalone device. So Microsoft built an excellent toolkit for mixed reality development called Mixed Reality Toolkit, MRTK for short. And this toolkit contains a well-maintained module called World Locking Tools, which provides a stable and reliable world lock coordinate system. And it actually locks the entire Unity coordinate space to the real world. And compared to the Magically PCF system, the MRTK world locking module is relatively easy to implement, as it aims to provide basic functionality with minimal configuration. Okay, so now I will show you a short Ubik demo of a multi-device collaborative scenario where a desktop user, an AR user, and a VR user meet in a real room that is represented virtually for the VR and desktop user. And in this case, this virtual model is just created with the LiDAR sensor of an iPad. And yeah, you can see here that there are some interactions going on, introductions going on. You can also see the speech indicators indicating that everyone's connected with their voice over IP connection. So it's quite easy actually to get this working across multiple devices, which is a major strength of Ubik. Okay, so in the coming time, I plan to post on the Ubik blog with more information on how to integrate Magic Leap's persistent coordinate frames with Ubik. And another thing to look out for is OpenXR support, which will simplify the usage of different devices with Ubik. So if you're interested in anything related to Ubik and mixed reality devices and SDKs, please reach out to me through email or even Twitter if you'd like. Yeah, thank you very much for listening. And I think we're going to go back to Sebastian with the roadmap.
That's right. Thank you, Nels. So I'll just wrap up by talking about future work. So the majority of the work the previous year, if you've been following, if you perhaps already knew about it, you've been following activity on GitHub, we were mainly focused on fixing technical debt so that we could start adding new features. So we done a lot of work behind the scenes over the previous months, and what we want to do now after the conclusion of our virtual environments module this year is add some major refactors and features. These include the logging and network stress testing features and mixed reality support. So these are pretty much almost ready, as I mentioned about the stress testing, for example, and they mainly require basic cleanup before they are merged into our main branch. We currently have a new round of students who are using it. This is the second time we've used it in anger in teaching. So we're hoping to get a lot of good feedback from them. As Anthony mentioned in the chat, our students, our master's virtual environments course, a good number of them are computer science students who come from the undergrad, but we do have a potentially very wide range of backgrounds in there. So some people who've never coded before will turn up. So we are constantly watching how they're getting on to see what kind of usability improvements can be integrated this year. So going forward, the major things we want to work on that are not so complete yet are the data persistence features I mentioned. So some sort of intuitive wrapper about something that persists longer than individual room. And the kind of use cases for this would be things like if you had very large environments, you wanted to spawn objects or object states that persisted between people visiting the area, for example, or to persist details about individual users or their avatars. We are looking at getting some of the things we've learned about scalability into Ubik, into the core samples, so that there are the benefits of those. As I said, the main challenge is that we don't want to build anything in that assumes certain types of interaction that are not quantified in some way so that you know they'll always be true. We want to be very cautious to avoid making assumptions that might break someone else's particular workflow or use case. But some things we could consider integrating, things like optional systems, say to do with Nimbus systems for audio, to raise that limit where the CPU falls over on less powerful platforms like the Quest, we could look at. A big thing is interaction. So Unity is going to deprecate the subsystem that we use for interaction at the moment. We are looking at moving to Unity's XR interaction system as the base interaction system. We just have to make sure all our samples are updated to work with it. And we also, the important thing about this is to make sure that our current samples remain just as readable. Obviously, if you have a system like Unity's XR interaction toolkit, which is meant to be general purpose, is meant to support many different use cases, it's in many ways harder to get to grips with. So we do want to make sure that where we do change it to use it natively, as opposed to our wrappers, that it is the samples do remain very accessible. Webxr support, I won't say much more about that. Ben's already covered that in excellent depth. Thank you, Ben. But we do hope to be getting that as a core supported feature. Quality of life features are more improvements to the server, specifically for visibility on performance, so what rooms are available, and just general administration features that could be useful for running experiments. And finally, programmatic peers. So let's take a tiny bit of explaining. So as Anthony said right at the start, Ubik is written, majority Ubiq code right now is written for Unity, but there's nothing that the design, I think in Unity, the design depends on. So one of the things we're really interested in is the ability for other environments, perhaps even other devices. For example, sensors of some sort is a good option. So like a spatially located sensor, this could be especially relevant for the mixed reality functionality, is for other languages like Java or other devices like microcontrollers to join a Ubiq room and feed data, spatialized data, into a Ubiq scene to control other aspects of the experience. And that will mainly take the form of us writing Ubiq basic network scene, complete with room client, peer examples of peers that run in other languages, hopefully with minimal dependencies, perhaps even show them running on some other devices as well. And those will become part of samples, which you can then build on, hopefully to do lots and lots of interesting things. So that's what we hope to be working on soon. And so I will stop speaking here and give back the talk back to Anthony and hopefully see if there are any questions.
Okay, we don't have a lot of time left on the Zoom. There are other workshops running, and I know some people have dropped off to go to other workshops that started already. I have to go to another workshop in 2 minutes. But the key thing is that thank you to everybody that's given a talk. This is the first big outing for Ubiq, and we if you've got, keep on asking your questions. The thing about Discord keeps coming up. We probably will get a Discord, I expect, because it doesn't cost. We have a Slack for other projects, but that will cost money for you to. So maybe a Discord is the future. But do email us either at ubiq@cs.ucl.ac.uk. You'll get all of us. You can post issues on GitHub if something doesn't work as advertised. That's quite effective. And otherwise, yeah, please keep in contact. And we'll make this recording will be available through the rest of the conference, but it's intention to actually just put it up on the website after some light editing to take me not speaking out and things like that. Okay. If anybody's got a quick question, we can answer it now. Otherwise, we'll keep on answering our questions on Discord over the next few days.
What about the HTC Vive Pro I support?
Shall I answer this one? So
yeah.
I think the best answer is probably maybe. So you could use the Steam VR plugin and their player prefab and everything will work more or less. You'll need to add the interaction handlers back onto that prefab. That might be the best way of doing it anyway, because if you want sort of features like eye tracking, then there isn't any way for us to access those through Unity's XR sort of package management system. So those kind of specialized features, probably better to use the vendors plugin. But as I say, relatively easy to take that plugin and amend it for Ubik.
Very good. Okay, well, I think we'll call it a day then. Thank you very much, everybody.
Who is talking?
Me.
I'm very
Somebody's talking.
confused.
Okay.
Okay.
Right, so I'll stop it now, and
Yeah.
we'll see stoppers at the rest of the conference. We'll all get a Ubik backdrop. You'll be able to tell who we are. Okay, thanks.
Sounds
Oh,
good.
bye.
Bye.
Thank you.
Bye,
Thank you.
everyone. Bye.
Bye.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye.